We had to do that a lot in 23 with our stinking sideways elevator and the arm that would come up with that thing. If that thing was off by a half a degree, then it would not place a cone. It was terrible. So we had to sit there with an inclinometer, a little digital inclinometer, and measure our arm height and angle between every match to make sure everything was right. We had a little chain tensioner where if it was off a little bit, we just give it a little bit of a tweak, and it would dial it right in. But we had to do that between every match, because otherwise we'd go out there and that thing would drop every cone on the floor. Post-match, if you had any issues on the field, right, this is the role, who's a technician in here? Anybody play the role of technician? That's your job. A lot of people don't understand what the technician does. He's the guy that holds the flag and drives the cart, right? No, this is part of your job, right? This is part of what you're doing. You're watching the robot. You know the robot. You should, anyway. You should have a good familiarization with the robot and how it's supposed to work. If you see it start doing something that it doesn't normally do, take note of that so you can let your pit know, and they can make those fixes. Again, find the root cause, resolve the issue, document it if you can, and implement preventive measures. Oh, no. Yeah, do a thorough pit checklist. Okay, cool. Follow a pit checklist with the pre-match stuff, right? So even, we'll do that all the time, especially when those guys want to go to lunch, you know? They'll be like, oh, we got our pit check done, Joe, and be like, oh, cool. All right. Can we do our pre-match functions check real quick and then go to lunch? Sure. Nothing's going to change on that robot between then and now, right? Hey, who knows? Hope not.
What's the difference in your pit checklist versus your pre-match? Is it just like nuts and bolts?
I'll let you answer this one, Dylan, since you guys decided to come to my class. Where's that?
Our pit checklist is going through and making sure, basically checking all the nuts and bolts and stuff, make sure they're all still tight, and also making sure that the things don't move properly how they're supposed to, and it's all with the robot off. And then our functions check, our pre-match functions check, is actually turning the robot on and making sure everything runs with it on. Basically.
That's what it is. Oh, let's see, don't forget, yeah, useful tips. Develop good processes and follow them. Like I said, the FMEA class, this one too, this is Dylan back there. I keep making fun of him. Round 4, you need to be going over wiring. That's one of the most common causes I've seen on robots of why they don't work. It's very seldom, hey, it's not running, the swerve module's not working because there's a bolt stuck in it. It's because a wire came unplugged, right? It's easy things. Big gears moving with a bolt stuck in it, that's gonna be a long fix. Loose wire, it's an easy fix, but it can sneak up on you really quick. So you wanna make sure all your wires are tied up tight. If they're not supposed to move, make it so they don't move. Dylan's back there just going. But yeah, everything on there should be very static. Go look under your car for a little bit. Look under your dash. Find me some wires that move around a lot. You won't find them. You know why? Because they make it so they don't. You want that to be like the robot, or you want your robot to be like that. Tie everything up. If you think you use too many zip ties on your robot, you probably didn't. Keep adding. They're cheap and light, and they make things not move. I think we had Duluth last year. We had our RSL come out and decided to become food for a swerve module. That was pretty cool. Still worked though. Everything worked fine after that. Swerve module was a little sad, but and apparently you can run a match without an RSL. That's not a disabled offense. Go ahead.
Our RSL popped off of its mount and swung and hit the main breaker and turned the robot off.
Yeah.
There's an awesome clip because I was driving
great.
and I watched it go off and I was like, oh, it's still working. It's just hanging by the wires. And then I drove forward and then it swung back as I stopped and it smacked it.
your robot had enough.
Yeah.
It was like, I want to be done now. I'm just gonna take a nap.
It was because the RSL was the highest point on the robot, so it got hit by the thing in 2024.
So what'd you learn from that?
We put it lower.
Put the RSL lower. Radios go up, RSLs go down, right? Put stuff on top of the RSL. They don't have. They have to be visible. They can be shielded. What? He's like, Joe wants to shield it. Yes. We learned a lot about that last year, right? Yeah. Big, huge piece of PVC dropping 6 feet. That'll do a lot of damage on electronics really fast. How many breakers did we go through last year in practice?
2 or 1?
2 or 3, yeah.
Do you use
Ours had a cool feature where the arm would go down like this. It still has it. Programming still has not fixed this. The arm would go down like this, and then the elevator would stow right into our belly pan, smash right into the breaker, and it would A, shut it off, but B, destroy the breaker. Like it actually broke it.
And then this guy did it in the systems check right before finals at state.
Yeah, at state in finals. It still hasn't been fixed. I love it. Programmers are awesome. Like, hey, Evan, you can fix that yet? Well, you know. All right. So, yeah, if they're not supposed to move, time down. If they are supposed to move, make sure they can. It's also helpful. Know your batteries. Again, Dylan's going to be doing basics of batteries over round 5 in Voyager. So that's a good class also. We love our batteries on 4607. We take very good care of them. They will take good care of you. Another thing too, if you're struggling with something, whether it's placement of your breaker or how to wire a thing, whatever, you need a part, talk to your teams around you, right? I push that a lot because how many times have you been over to our shop to grab something? Right? We're here to help. Everybody's here to help. You know, just you gotta ask somebody. And also accept help, right? I'll have that one happen every once in a while too, where I'll be at a event and I'll see a team that's struggling with something, and I'll go over there with Dylan or one of the other guys and, hey, what's going on? What do you guys need something? And oh no, we got it. Well, do you? I mean, not gonna do it for you. That's not what I do, but I'd like to help you get to where you want to be. You know. Anyway, accept help if you're able to. These are just a couple other little final things, and we'll wrap her up. But be the team that others want to work with. Keep a clean pit. We've all seen it. You go to that one pit at competition where they just got debris everywhere, and they got 50 zip ties on the ground because they put too many on because Joe said so. Or you've got other chaos going on. People notice that. Teams notice that. Hey guys. Right. So just remember that. If you're fixing or working through a problem, work through it, and then do a little bit of cleanup. Dare I say that's what freshmen are for? No, that's me. But get a little cleanup happening. That's how people learn where stuff goes. Get the parts cleaned up. If you do have major problems, one of my biggest rules on 4607 that I like is don't ever run. You know, they say don't run in the pit. People still do it, you know, but hopefully you will never see us freaking out. What happened to us in, what was that, MRI? MRI, yeah. Motor broke. One of our swerve motors blew up on us. What are you looking at me for? That's right? You look at me.
MRI.
Yeah, that's what I said.
Magnetic resonance imaging?
No. MRI. Minnesota Robotics Invitational, Roseville.
Oh.
Yeah. Then here it comes to the pit because we're sitting there. The guys are working on it, replacing the motor. He comes to the pit. He's all panicked. Why is anybody freaking out? Fix the motor. Right? Be cool. It'll be all right. It ain't hard to fix a motor. How does your team react to challenges if you are having challenges? We're there to learn, we're there to have fun. It's a competition. I like winning things, that's fun too, but are you learning? Right? That's the most important part. And if you're having challenges, are you learning from them? I love it when the robot breaks. Don't tell anybody. It's fun to learn. Body language, people pick up on that too. Be aware, if your team's not doing well, or, there's, like saying earlier, to win a competition, you need to be in 2 places. Well, maybe 3. You can be the number 1 seed. That's a good place to be. You need to be about 28. And if you're 28 and you got good body language and things are going well and you got a robot that's consistently doing the same thing over and over again, that's a great place to be. That's how we ended up on Einstein's in 23. Our robot was not special. It was just good enough to not get picked by all the other guys and then make it back around to the last pick. Sweet, I'll take it. Compete with the robot you built. Make sure when you're working with other teams, you're, when you're doing your match strategies and stuff like that, hey, we're going to run this auto. Run that auto. Don't surprise everybody, please. That'll not go well for anybody. Hey, we're gonna place here, here, and here, and then we're gonna go play defense. All right, cool. Execute that plan. If something comes up, make sure you're communicating with the other drive coaches and stuff like that, so everybody knows what they're doing. But for the most part, please, it's good to execute the plan that you said you were gonna do. Climbing. Oh yeah, climbing at the right time. That one was really frustrating for me in 24. After we finally got our climber working, that we had working but didn't know it, then we would go climb, and then nobody else would, because you needed 2 climbs, right, to get the RP in that one. That one drove me absolutely nuts. I'd watch every match and I'm like, oh, they climb, they climb, they climb. Then we'd play with them, and then they wouldn't climb. Oh, I want that RP. Oh well. Have a pinball robot always move. That kind of goes back to what I said in the beginning, right? Drivetrain, drivetrain, drivetrain. The most important part of the robot. Let your robot do what it does well and consistently. If all your robot does is score on level 1, but it does it consistently every time, do a lot of that. Slow hits are worth a lot more than fast misses. That's another one. I like that one. Improve as you go. The teams that want to be picked, you want to be picked by, yeah. The teams that you want to be picked by will notice the improvement, right? So if you start the regional out with something not quite working right, and then you start tweaking it and start working, sweet. Remember, that's not an auto. Don't do that. Maybe you have to, I don't know. But keep an eye on that. Be ready to talk. You should know why, if you're wondering if you're going to get picked or you're going to be picking somebody or whatever the case might be ready to talk. Have a good idea as to why your robot would be a good fit for an alliance. I've had to tell other teams not to pick us before. Like we've had to have those conversations where, hey, I don't think we would be a good fit because we run this auto and you run the same auto and we don't have a different one. Do you? No? All right, well, it's not going to work well. Have a conversation. Use the communication you're able to do, and that will hopefully get you on an alliance that you're better fit for. Don't have to be a used car salesman if somebody's coming up to you asking you about your robot and trying to figure out if you're going to be a good pick or whatever. Don't tell us it's a single owner, a little old lady drove back and forth to church, right? Just what's going on with your robot, what's working well, what's not working well. Here's what we've seen on our scouting data. Do you have any issues with that information or that data? Last, and we'll see if we can answer some questions and stuff. Have someone in your pit, please. So you've heard me say it now. Have somebody in your pit during alliance selection. Not everybody has to be in the stands. It's exciting. The poor pit crew folk have to stick around. Just have somebody in the pit. Why? Why is it important to have somebody in your pit? Not you, you know why. Go ahead.
Say in case a team comes up and wants to talk, but if you're not there, they can't talk to you,
Yeah,
and they think.
things get, you gotta remember when remember the picking process at the regional, right? 1 picks, 2 picks, 3 picks, up to 8. Then 8 goes back down. 8 picks their second robot, then they pick their third, and then it goes back down. By the time it starts going back down, that pick list that every team made, that 1, 2, and 3 seed, that pick list they have, is starting to get silly. Shoot, that guy picked that guy and I didn't expect him to, right? Things start getting weird. That's when I'm getting text messages, right? That's when my strategy team that's out on the floor working with alliance captains typically, because we're never one of them. That's when they're starting to figure out, okay, who's our second pick going to be? And then pit folk at 4607 are going to get a text message. They're going to say, hey, go check out Spud Inc. What's going on over there? And I go over to their pit, and Dylan's going to talk. Nobody's there, right? Okay, well, look at a robot a little bit. Looks okay. Looks like a robot. So have somebody that can speak to your robot or speak about your robot in your pit. Not everybody has to be up in the stands for the fun part. I know it's super cool to watch, but somebody should be there. Yes.
I blame the coaches. They made me leave the pit.
Well, and that might be your team's process, right? At 42-39, we never had anybody in the pit. It was always just the way we did it because we didn't know any better. So maybe that is your team's process, and maybe you just haven't thought that through. But it would be very wise to have somebody in the pit because that conversation might become important. Especially if you're starting to get looked at as a second pick of the number 1, 2, or 3 seed. That could be a trip to Houston. Who knows? So have somebody in the pit. All right. Questions? We'll open it up for questions, comments, concerns, or any accusations. Yes, sir.
Is there anything that makes a team not end up on a pick list no matter what for you guys?
So the DNP side of things, right? There'll be a few. It's kind of more game dependent, right? Like, hey, this team doesn't have what?
Charlie wanted us to let people know that there's designated parking for the event. And
So let them know.
yeah, so there is designated parking. So SCSU will ticket people who are not in designated parking. I believe the parking ramp is one of the designated parking locations. Otherwise, you can talk to Charlie at the front desk as well to if you're wondering where designated parking is.
All right, programming, everybody, give me a hand. Thank you. So back to your question, right? So is there something that'll land you on a DNP? If, for like this year, if you didn't have a deep cage climb, would that be a DNP? It'd be some pretty bad marks on you. It'd get you close to a DNP, right?
A big one for us
Yeah.
is teams that don't do what they say they're gonna do. You
Yep.
do a match strategy, and then they go out and do something completely different than what you discussed.
Yep, that could be a big one too, is just that type of repeated poor communication or something like that, or holy cow, they're just doing whatever they feel like. That could get you there pretty quick as well. Yes, sir.
If you go back a couple of slides, you had a typo, ASAP as possible.
No, I did that on purpose.
Are you sure?
But thanks for trying to call me out. Appreciate you.
Welcome.
Where?
Still
I can't remember doing it, but it sounds like something I would have done. I'll take it. Watch The Office, it's funny.
Hey.
Other questions? I think we're good to wrap up then. Nothing else. All right, well, thanks for coming. Hey, before you all bug out, thanks for coming out here today.
You're welcome.
It's a Saturday. It's a great day to stay inside and watch football and eat chili and not do anything. And you guys came out here to do this, and that's awesome. So give yourselves a hand and get the heck out of here. Go to the next one.
All I know is it's Mom, where are we up to next?
Starts out over.
We have
Any ideas or?
For good questions, yeah.
I don't know then.
I don't know. Yeah. Where are you going? Oh, hang on. I have teammates to ask questions. Where are you guys going?
Next island. Oh, sure.
This is the most impossible to believe. I don't know.
Okay, awesome. Thank you very much.
Well. I also watched them. Also based on his music, March 17th at 7 p.m. Get back on my feet. I think it's beautiful. I also think it's beautiful, but sometimes I'm pretty
But that, so just put it. You can't even make one as good as.
No, okay. It's like record like clips. You know how like it's the first person's like when you ask do this, here's what you should do, and it's like a clip. Like
But it'll never be as good as Abel's presentation. Well, you gotta get your sister to come again for that, because she was really good at it.
Well, get my sister kind of like feeling like a big house. Oh, that'd be great.
You have video of these what right answers.
What to do and what not to do.
Right?
I'll ask them both what they're doing. Actually, I'll do fundraising instead of bill. Just like you want to do bill. Bill's easy. It's like so
That was the one that is that.
This is my second.
Why does Simon have Simon do bills for design, not bills? We always have so many. So He's gonna take me back. So it's getting together.
I need to talk to Chris.
It's sounding pretty quiet out there. I'm gonna give it maybe like 1 or 2 more minutes. How's everyone doing so far?
I'm doing good.
Good.
Really good. You're from Becker?
Yeah, I'm from Becker, so
Awesome. Would you wait? So did you graduate from Becker?
I did indeed. Yep.
Awesome.
And then I actually went here for secondary schooling. So.
Oh, that's awesome.
Yep. So I gave my capstone, senior capstone project right across the hall. So
Pretty cool.
been around the block a little bit. So
Yeah.
how close are all you guys to graduating?
I'm a senior, so I get to get out of here.
Let's just go down the line since you guys started. So
I'm a sophomore.
sophomore.
I'm also sophomore.
We got one more down the line. It's all good. No. Don't worry. No. All right. That's fair. I know if I start, someone will always walk in and I never want to make a person feel bad, so I just
gonna give it one more minute here, and then at 10:20, I think we're gonna go ahead and get it started. So, otherwise, how far is the drive for everyone? Is it
About an hour and a half.
an hour and a half?
Depends how many people they pick up.
Well, you guys, how far was your guys' drive?
I'm driving half an hour.
Was it?
Ryan's driving like 2.
2.5. Where you? Oh, okay. Thanks for being here. So, but all right, I think we're going to go ahead and get started. So, yeah, welcome to the presentation. This is Safe and Efficient Teams. I'm Mitchell Sockrey. I am the safety manager for GNR and GCR. I sit on the planning committee for both of them. I'm originally from 4607 CIS. My background is I'm a manufacturing engineer. I'm actually a manufacturing engineer at UMC. I've done a lot of continuous improvement type of work, along with just manufacturing molds, dies, and now at UMC I do a lot of tooling and process development. So, just kind of an overview of what this is going to be. I get a lot of questions now, especially since when I was on the team and the safety captain at Becker. Safety has actually changed a decent amount in the landscape of FIRST. I know now how they're trying to attack safety, especially being in the position I am. I'm glad for that. But a lot of teams ask me, where do I start? What do we do? How do I know I'm being safe? What is a good culture on the team? And we're going to go ahead and kind of break it down to, basically I'd say there's kind of 3 tiers of a team when it comes to safety. So the very first is instilling a culture of safety. We're forming it. This could be a new team, or this could be a team where, say they're maybe restarting, trying to start their safety program back up. It could be a team that's 10 years old and saying, hey, safety slipped a little bit. We want to get back up there. We want to build that strong base. We want to build that strong culture. And then the second stage I'd call is norming, which is, okay, now we got that strong base. How do we build this up? How do we make this culture our own? How do we do things that make sense to us? How do we build upon the safety system that FIRST has provided us? And then the third step is performing, where you go above and beyond. And I'm just going to talk about some of the tools that I've used. And I can say that I became a manufacturing engineering technology. That's my degree. And I went into that route because it's heavily focused in continuous improvement. And that is because I got into safety at robotics, and I got into that continuous improvement mindset there. So that's how I more or less figured out my path going forward after high school. So I'm just going to talk about some of the tools there. So just to start, what is safety? Honestly, this is we're going to do a little bit of a open session. What does safety mean to you guys? Go ahead.
Making sure people don't get injured and that they know what they're doing.
Making sure people don't get injured and know what they're doing. Anyone else? Go ahead.
Say if something were to go wrong, how to step away from it. So that would be a part of safety as well.
Honestly, both very good answers. Anyone else? Anyone else? All right, so I'd say that basically you guys answered like how I would answer it, and there's no wrong answer. There's kind of 2 ways I'd answer. The first one is safety is preventing hazards and injuries before they happen, and if a case actually comes up where that does happen, how we properly react. And even that, I'd say, is a little more complicated than it needs to be, because at the end of the day, safety is going home with all your fingers and toes that you came in with. Like, just to be blunt. Like, really? We want to make sure people don't get hurt so that they can come back in. And we don't want people to get hurt so that, now they're at home, it's bad for them to be at home. We want them to be here having fun. And that's the goal here. Because I know being one of the safety managers, at regionals, people sometimes run away and stuff. It's like, no, I'm here to help out. If people want to talk about safety, they can. You want to talk about engineering, I'm right there. We're all here trying to have fun and just trying to make sure that no one has to go home, no one has to go to the hospital or anything like that. So, in terms of forming, there's actually a pretty good resource that FIRST has provided us, and that's the FIRST Safety Manual. This is what I call a baseline or minimum for all team safety program. This is where, again, if you look at my bottom right, I'm going to have kind of like roughly this is forming, norming, performing kind of thing. And this is a baseline for all team safety programs. This is a good real model that is a pretty good idea. And I would say that all participants and the different team levels should be familiar with this. Even if you got your team that's performing, going above and beyond, knows safety through and through, this is still their Bible. You should still know exactly what's in here. And I say exactly, you should be familiar with it. You don't have to be able to recite it through and through, you know, oh, you gotta do this, you gotta do that. No, just know that this is a thing that exists, it's something you can go back to and reference. And in this section, in this manual though, it does a very good job. It's changed quite a bit since when I was a safety captain, when I was sitting in your guys' shoes. Because when I was on the team, there's basically only 8 sections. Now there's 11. And with that, of these 11 sections, these ones on the right, I'd say are quote-unquote the easy ones. These are the ones that make sense. You know, if we're talking general safety requirements, personal protective equipment, you know, you read through that, it's pretty, yeah, that makes sense. You know, I know what personal protective equipment is, or I can figure out right then and there what that means. I want to focus on today for the forming section, the stuff on the left. This stuff is, what does culture mean? Who is responsible for safety? The actual safety in your workspace, and I want to go beyond just your workspace, like what does it actually mean on your team? It relates to a culture of safety, but how do you actually invoke that onto your team? And then Appendix D, it's more or less Section 11, I think of it as, but that's specifically for FRC robotics, and that's where it breaks down what a good safety program looks like, and then also what the role of the safety captain is. So, I'm not going to read this verbatim, because you can go and look it up, but I just want to have it up there that, first and foremost, Section 1 is a culture of safety. What does that mean? Even reading this, it just says, more or less, you should have a good safety culture, which is 100% correct. What does that look like? What does that mean? And to me, actually, hold on, what does that mean to you guys? Hopefully you didn't see that little bit. So, what does that mean to you? What does a good, healthy safety culture look like? Go ahead.
That people do safe things without being told to or asked to.
Awesome. Back there.
Everyone on the team understands what the safety precautions that we should be following are.
Perfect, perfect. Both those, I mean, that's basically what we want safety to be an instant. We want it to be second nature. Just like we said, you know, we don't want someone to be, oh, you know, hey, I see the safety manager's coming around the corner, you better put your safety glasses on. We see your mentor is coming around the corner, oh, you need to put it's no. Hey, you don't have your safety glasses on, put them on. We want you to, you know, we don't want to get stuff in your eyes. I've had stuff bad in my eyes before, guys, and like, I know some people really don't like wearing safety glasses, and I wear safety glasses over my glasses. I can tell you that I will do that day in and day out, because I've gotten fiberglass in my eyes and metal shavings. It's not fun. You got to go to the doctor. They do their best to wash it out, and I mean, it's not fun at all. And I am an absolute wimp when it comes to getting stuff in my eyes. Like, it's not fun. So, I would say that a culture of safety is we want safety to be instinct or second nature. We want people to just do it. It's not, well, leading into the next section, it's not just the safety captain's job. It's everyone's. It's through the whole entire team. If you have someone that's saying, oh, you know, I don't need to worry about that, no, we all have to. We all need to make sure that we're watching out for each other, that we're doing a good job to keep not only us safe, our teammates safe, and other team members safe. Or even, you know, if you're walking around at a first regional, and you see maybe there's someone walking around that's, you know, they got their kid or something like that, and they don't have safety glasses on. It's like, oh, you might want to put some safety glasses on. You know, you can go to the pit admin or, you know, the front table for safety glasses and grab some. So we want to make sure that everyone is responsible for safety. And I use safety glasses a lot just because that's, I think, the kind of best example and the simplest. But I mean, you can go through and through. Even with, say, a lot of teams nowadays are getting CNC machines, and I kind of go into this a little bit later. But CNC machines, I think, is one of the next black boxes for teams, just because you can do so much with them. But those machines can do, for lack of a better word, so much to you. They can really tear a person up. And even with plasma tables and things like that, you got a gantry moving around. You don't want to get hit by that. You don't want to get pinched. I used to work with welding robots, and I can tell you that the max speed of a Fanuc or Fanuc welding robot is 400 millimeters a second. That might not sound like a whole lot, but 400 millimeters is pretty quick when you're standing next to a robot. When its welding arm flips like this in basically 1 second. And the welding is like a spear, basically. So a lot of machines, I mean, even the robot itself, it can act in unfamiliar ways. So again, we want a culture of safety. and everyone's responsible for promoting that culture of safety. So again, just to be 100% blunt, it's everyone's responsibility to be safe. I will go into a little bit later what the job of the safety captain is, because I'll just get into that later. I don't want to get ahead of myself here. So, safety in your workspaces. This is a huge section. I took just basically 2 snippets. This is past kind of the first big section of it's the general safety requirements. This is just, when you're working on stuff, use gloves if you're lifting up the robot. That's in transportation. That's section 5. Section 4 is PPE. This is where I'd say the next section is, but the biggest thing I want to focus on is maintain a healthy attitude regarding to safety. And basically with that, we want to make safety fun. We don't want to make it a joke. And what I mean by that is, if you have someone coming around and saying, oh, I had my shoes untied, safety guy, why don't you say that? It's like, again, this goes back to everyone's responsible for safety, but 2, you don't want to make it the butt of a joke. This is something that, even in industry, people try and badmouth it, but especially here, we want to make sure that safety is something that, you could go to a safety captain and say, hey, we've got a problem here, and it's, the example I'll use is, do you guys ice fish? So there's tip-up fishing when you're going for like northerns and bass, and there is basically when you get a fish, a flake goes up. And there's one time we had a friend that he was new to fishing, and he just goes, flake, and we look and we're like, where's the flake? We don't see it. It's just my dad and I'm his friend. And it's like, the guy's like, oh, I'm just joking. And my dad, he takes fishing pretty seriously. He's like, don't ever joke to me about that flake going up. And that's, in a roundabout way, kind of the same way we want to be with safety. We don't want to make it a joke. We want it to be that, hey, if there's a problem, we take it seriously. We want to make it fun, though, because we don't want it to be this, oh, I'm the safety captain, so you need to do what I say. No, because I'll get to this a little bit later on, but the safety captain is a very important role, and basically we want that person to be someone you can trust and go to. And another way just to make safety fun is, do you guys have large group meetings or regular meetings or something like that? How often do safety captains talk at those meetings? My challenge here for you guys is at one of those meetings, just have something about safety. And I don't mean, we got to go over this section of the safety meeting. Just, hey, you guys want to hear a joke? Here's this joke that I learned, and then you you start up with an opener, make a joke, then you ease into something with safety. You want to make that, again, a culture. So talking, in industry, there's things called toolbox meetings. And that's just, we get in, we talk about, hey, here's what we're looking for in the day, here's our production numbers, here's maybe a safety concern we had. And a lot of times, in those toolbox meetings, they'll have a joke or they'll, play maybe a little game or something like that, just to ease into it. We just want to make sure that safety is fun. We don't want to be the Gestapo. We don't want to be cops. We want to make sure, hey, good job. That looks like you're doing things safe. Or hey, I don't think that's a great idea there, pal. Let's try and work on it. Basically, in terms of actual safety, if you can, this is section 11 and this is new. This was not on the team when I was here, and I think that this is a pretty solid idea of what you want to be looking for in what I would consider a good baseline for a safety program. If you can actually have team members, don't just the team member, helping ensure participants and volunteers are doing things safely, that you're motivating everyone to do a safe and good job, that we are actually empowering and giving people the tools to be safe. That, I can go on and on. If you can follow this list, I would say you have a good baseline and you have a healthy safety culture. And this is where, so once you have this, you will have formed your safety culture. I'd say you have a good baseline and you can start moving on. I want to say a very special point to this. This is new. To be eligible, I'm going to read this verbatim. To be eligible for any first robotics competition award, teams will now be required to show how they pursue or expose first core values and a culture of safety in addition to demonstrating gracious professionalism. Long story short, we all know how important gracious professionalism is. And first, they are now holding to the same standard, safety to gracious professionalism. So if we have teams joking around, messing around, doing things that are unsafe, horseplay, technically speaking, for this, that may violate you from an award. And I can say that ever since first got rid of the safety award, I am glad to see this back, just because we need to make sure that we are helping promote that culture of safety. I mean, back in the day, and they still do say that safety comes first, and we want to make sure that we're following all of that. This is where I want to take a good portion of student safety captains. We talked about, everyone's responsible for safety. How does the safety captain play into that then? Basically, the safety captain is there to instill a culture of safety. They're there to help push in the right direction. They're there to help motivate people. If you need to actually, if you see someone doing something unsafe, have you ever heard of the phrase, praise in public, reprimand in private? That's the job of the safety captain. You want to make sure that, hey, you're doing a really good job there, like how you had that clamp down when you're drilling on it so it's not flopping all over and hurting someone possibly. You say what's actually, someone's doing something good, but you want to make sure you say that in public. You don't want to bring them around the corner and say, hey, you did a good job. Okay, why else, everyone wants to be told they're doing a good job. So if you do that in public, well, I want to be told I'm doing a good job, so maybe I'll brush up on a couple things, think things a little bit, through a little more. People want to be told they're doing a good job. And people don't want to be, heckled. They don't want to be saying, oh, hey pal, I don't like the way you're doing that, they don't want to be embarrassed. So we want to make safety fun and not a joke. We want people to make sure that they can come to us saying, hey, I think there's something that is maybe a little unsafe. I think that there's something that, we could be doing this a better way. And then in the same vein, we want to make sure that, I would say, when we're talking about presentations and things like that, or how do we actually instill that culture of safety? When I was on the team, we made just little marketing type stuff. I did this myself, and it's just a thing of, hey, you're doing a good job. Here you go, hand it out. It's a little first aid kit, with the logo left on there. And our logo was, be safe, smart, alert, focused, educated, up there too. So we want to make sure that we are helping promote that. We're making it fun. Someone needs to go, hey, look, I got this for doing a good job. Seriously, the human mind really likes being told they're doing a good job. No one wants to be told, hey, you're doing something bad. We want to help build them up. That's when I'm at regionals, and I see people, some people, not all, scatter when they see me coming around the corner. It's like I just go and talk to people. I'm an engineer myself. What's going on with the robot? That's neat. I like seeing that. So it's, again, we want to help build up that culture. And that's the main job of the safety captain. I will say that I know myself, safety captain is a tricky job. It's a lot of responsibility. It's a leadership role, and you have to be a role model. I know some teams have actually done a couple interesting things, and I'll just say this here. Some teams will split the role. You have maybe your more administrative safety captain, and then you have your more hands-on safety captain. The biggest thing I can say, and the biggest piece of advice I can say about safety captains is you can earn respect or you can demand it. One of those works 100% of the time, and one of those doesn't work at all. I shouldn't say 100% of the time, but if you earn your respect, it's going to stick and work a lot better than someone that tries to demand it. And at the end of the day, again, we want to say, we're not cops, we're not the Gestapo, we are not saying, hey, you did a bad job. We want to be there to say, hey, good job, I like that. Why don't you share that with the rest of the team? That's another thing during meetings, we go and if you are speaking at the meeting, bring up and say, hey, I saw Dylan, and he was doing an excellent job making sure that the piece he was cutting was clamped down and wasn't vibrating too much on the bandsaw. Or, hey, when we were on the mill, I saw he was taking extra precaution to make sure that the work holding was tight and making sure that he pounded it down so it didn't fly out through the window. So again, we just want to make sure that with safety captains, we are here to help develop that culture of safety. And this is a good little system here. This is the CTCE system. Any industry can use this, any form of leadership. But with safety, you can create and revise policy. This is technically done because we have the first safety manual for just forming and developing that baseline culture. But then you want to train it. One thing that I know a lot of teams do they might do a little test. And when I say a test, I don't mean, you gotta study up, you gotta make, here's your printout, here's your Scantron, go ahead, fill it out, you're gonna be graded. No. A Kahoot's still a thing, right? I've been out of school for a little while. Make a Kahoot, make it fun. Hey, here's some rough stuff in the safety manual. You want them to be able to crack open that safety manual, scan through it, read through it, become familiar with it. They don't need to know it heart by heart, word for word. You just want them to have a little bit of fun. Say, hey, here's a little test. Let's just have some fun. You want to coach policy. This is the next thing of what we talked about with you can praise in public, reprimand in private. Because if you coach and you properly push people in the right direction, you want to build that culture of safety up. And that way, you will never have to actually enforce. Because enforcing is the reprimanding. Coaching is the praising, enforcing is the reprimanding. If you do training, make good policy, revise policy, and coach policy, you should never have to enforce. And I can say that truthfully because when I was on the team and as a safety captain, it was one of those where you always had your guys that would push your buttons, push the envelope a little bit. But when you gain their respect, they are on your side through and through. You can go through thick and thin with them. And if you do the first three great, you might have to do the enforcing a little bit, but it'll taper off to the point where it's basically you won't have to worry about it. All right, so we talked about forming. We talked about section 11 where, hey, if you have a good safety culture, you have a good foundation, a good base, this is what it should look like. There's the responsibility of a safety captain. Now, what else does your team need? We have the safety manual, but every team's different. Like I was talking earlier, well, some teams have CNC machines. Some teams have manual machines still. Some teams have big trailers, some teams have little trailers. We need extra information of how to properly load that trailer. What kind of training do we need? Does everyone get first aid training? Do we need fire extinguisher training? I would say yes, but just what else does your team need? And that's where I go to I would recommend your team make its own manual. This is the one I made back in 2018. I dug it out, and it's still around, but it's been built on and revised for different things. I'm going to go through in reverse order because we're going to be running out of time here. But actually, not in reverse order. I fix that. So, travel emergency safety. When you guys go to different regionals, do you talk about an emergency like planning area? If there's an emergency, we meet here. Where's the regional at? Where's the hotel at? Is that documented anywhere? How do you make it so that next year, when we have team members leave, how do they know to do that? Put that in the safety manual. This is documentation. And my biggest thing that I want to say about anything policy and safety related, don't do it for the sake of paperwork. If you're doing it for the sake of paperwork, it's completely just waste. You want to make sure there's reason. If you need data to say, hey, we're getting a lot of injuries on this thing, maybe we need to form some training for it, that's fine. But if you're just doing something because, every other team does it, no. Does that mean it's right for you? Required trainings, first aid training, fire extinguisher training. There's really easy, you can honestly talk to most fire halls, and they might have a fire extinguisher training type thing. CNC training. Keep it logged who is trained in what. Because if you want to take it that step further, it's say, hey, when we're working in the shop, we need someone there that is first aid trained and fire extinguisher trained. So if anything goes wrong, we've got someone that knows what to do. Trailer loading procedures. This is one from when I was on the team. This version of the manual doesn't have it, but that year, I'll say we wrecked a trailer. We had loaded it improperly to the point where there was too much weight on the back, and we wrecked an axle. We had brand new Milwaukee toolboxes. We had the great big cube pit. I don't know if anyone remembers that from 4607. It was a lot of weight on that poor trailer, and we didn't load it properly. So we brought in a load securement expert. He talked us through, you want to put all that weight as far forward on the tongue. You want to keep it over the axles, keep it off of the back. He loaded it properly. Then he went through a proper strapping procedure. We got a new trailer. We put in E-track. Oh, that was so much easier. It clipped right in. You don't have to worry about messing around with little D-links or anything like that. Worked great. And just even in that same vein, we carry a lot of stuff in our trailers. Toolboxes. You ever have a toolbox break loose and go through? I mean, that's, I don't know, a couple 100 pounds. And it could be going into a family of 5 in a car down the road. We don't want that to happen. So I take load securement very seriously. I have an agricultural background, so we're hauling heavy equipment every once in a while, loaders and things like that, and it's a scary experience when something slips. So we want to make sure that doesn't happen. And then lastly, shop/working times. This is another real story where it is in this version of the safety manual. We had a lot of burnout on the team. We had people pulling all-nighters, and just that wasn't good. So in the safety manual, we talked about a leadership meeting. I don't think people fully grasped it because Alex here case still talks about it. We had set a schedule for when the shop is open and when it's closed, because at the end of the day, you got to go home. There's homework to do. You know, we want to make sure people are able to go to the events. And all of a sudden, you know, like season just started, we're working in the shop, and I walk up to Alex here and I go, "Hey, shop's closing in 30 minutes." And he goes, "What? We got stuff to do. We got to keep going." It's like, "No, cleanup time's in 30 minutes. And he kind of sat there, looked at me. I showed him it in the manual. He had agreed to it along with the rest of the leadership team. And he goes, "Yep, no, it's time for us to be done." So we started cleaning up, putting all the tools away, and it was a much better year. We had a lot less burnout. We had people, they'd go to bed, and when they come back the next day, they'd be, "Oh yeah, that thing we were going to do last night, I completely redesigned the robot. Yeah, no, that wasn't going to work. This is a far better idea that saved us a lot of time." And that happened 2017, my first year on the team. There was one night where people completely redesigned the robot, and we took a tape measure to it the next morning, and it was too tall. That saved a lot of time. We prevented that from ever happening. So I recommend, if you have issues with burnout, try and say like, "Hey, you know, go home. It's fine. We'll come the next day." And it's especially better now that there's no longer bag and take, where it's a lot more time allowed, and it's a lot cram. You know, right at the end, we gotta go. We gotta get it done. And you'd be surprised by how getting a good night's sleep can save a lot of problems. So now we're getting to performing, and I just want to make sure, are we done here at 50 in 2 minutes, or is it a little bit longer than that? 11:10. Oh, okay, we're gonna have plenty of time for questions. That's what I want. So now we're getting into a couple things here where this is things that you don't have to do this. This is things that I learned about when I was a safety captain on the team, and these are real things that I learned about in college, and I actually use in industry as an engineer. And we'll just kind of go through it here. There's this concept called design for X. And most of the time, I don't know if you guys have heard, it's designed for manufacturability, designed for assembly. It's normally put together as DFMA, designed for manufacturability and assembly. But then it can also be designed for repair, so on and so forth, whatever you want, throwing it in the X. The goal of this is to, when you're designing something, to put it in the perspective of, does it make sense? Because you can design something to be machined super easily, but then it literally has probably double, if not triple, the amount of parts you got to put together. Which maybe that's fine. For us, you know, as a robotics team, well, we got to repair it, so it's maybe easier just to unbolt something than put it together, or, you know, if it's welded, well, now we got to re-weld. I want to look at specifically design for safety. This is something that actually gets done in industry, where you put on the safety goggles and you look at this and say, is there anything here that isn't safe? A lot of times you can do this in like a FMEA, which I think there's another session on, failure mode effects analysis, where we analyze like all past failures and things like that on a robot or anything of that like. So robot design. In 2018 again, maybe it was 2019, either way, there was a robot that had basically an arm, and in order to actually service it, you had to flip the arm up. Well, it was a lot of work to flip it all the way up back and flip it all the way forward. So a bad habit started to develop where they just lift it up a little bit and there's just enough tension most of the time to keep the arm up. Well, every once in a while it'd fall down. That's not good. So it was a real simple, how can we design this better? And we know there is different options of, oh, you know, we can use worm gears or something like that to lock it in or anything of that sort. Simply, we just put a kickstand on the robot. We drilled a hole in the side of the arm, bent a little piece of metal, so then when you lifted the robot up, the arm up, you put a piece of just a little bent rod, and it helped the arm from falling down. In that same vein, again, the section 3 of the safety manual, general shop safety, that says that when you work on the robot, all forms of energy should be relieved. And the easy stuff is, you know, I believe the exact wording, because it has changed, is it is highly recommended that it should be relieved. Because technically there's some times where you gotta do tests on the robot while it's running. I just say be extremely careful and know exactly what you're doing before you try and do something. But in that same vein, the safest way is shut the robot off. Does it have pneumatics on it? Drain the tank. But then there's other things that you might not think about, like mechanical energy. Is there springs that are tensioned? Relieve those. Make sure that it's not spring loaded so that someone accidentally takes something apart in there and it explodes in their face. And then in that same vein, that arm, technically that's gravitational energy, potential energy. It's held up, it can fall to a lower state. So we just want to make sure that when you're designing a robot, you have that lens of, is this doing anything that would be outright dangerous that could hurt someone? We don't want that. And I can say too, it's better to design something into a product than to try and fix it later when it's already designed. Because then your hands are kind of tied. Like for us, it worked out that we had a lot of real estate. We just drill a hole in the side of the arm and put a little kickstand in it. It was perfect. Sometimes, the robots, they're getting a lot more complicated than when I was on the team. And it's a lot trickier to maybe make that little tweak here and there. Pit design. I don't know if anyone here remembers, 4607 had this great big cube. It was really awesome, looked really cool. It was really heavy. Again, that was part of the reason we wrecked a trailer. So then we redesigned it because you'd basically bring it in, put it all together, you'd have 4 students pick it up, put the 4 legs underneath, and it was pretty heavy. I remember being in much better shape, and that was still a tremendous task to pick that up and have someone move the 4 legs. So then we said, well, that's kind of a lot of work. It's, maybe we do something different. And that's where the current pit is at now, where it basically hydraulic, or it's got linear actuators that lift it up, and it's basically just 2 workbenches. Well, even that's really heavy. It's a lot of weight on the trailer again. It's a lot to try and push it in. It's all steel. So now there's talk of maybe moving away to something a little lighter. There's a lot of aluminum. There's those like band cases that I see a lot of teams use, where you just open it up and it's all right there. It's aluminum, it's wood, it's lightweight, and it's even efficient to just open it up. And I'll take a little second here to talk. People like to think that safety and efficiency are opposites. They are not. They are related very fundamentally. We're going to actually talk more about that in the continuous improvement section. But do never think that, if we are being safe, that is going to waste us time. That is not a healthy culture at all. In reality, it'll probably be the opposite, because you'll try and do something quick, someone gets hurt, well now, that person has to, they got a massive cut, maybe they had to go to the doctor, go to the hospital, and we don't want that. We're down a guy. And that's even how it works in industry too. Because in industry, there's workman's comp, so the guy gets hurt, well, now he's sitting at home because he can't go to work. He's got or he has to do light work, which just doesn't help anyone. And then workspace design. That's basically ergonomics. I'd like to think I'm on the taller side of things, so if I'm working like here, well, someone else's work height can be maybe down here. So I'm crouching down for their work height, well then they're trying to get a chair or something to work at my work height. Make things adjustable. Can you do different work table heights? Sometimes it's not possible, sometimes it is. If you have certain tools that are right-handed versus left-handed, do you get both? Do you get maybe one that's universal? There's different options for workspace design. And that's seriously, that in and of itself is a whole industry. It's ergonomics. Everyone knows about ergonomics nowadays. And if you don't have good ergonomics, it's called MSDs, musculoskeletal disorders. And those are not fun, and that's the most common cause in the industry of why people can't come into work. You tweak a back, you tweak a muscle, it's just not good. So design for safety, you can look at that in any aspect, the robot, the pit, the workspace, anything. 5S. I learned about 5S when I was on the team. And I did not know that it was part of something called lean manufacturing, which that in and of itself is part of continuous improvement. And I'll work my way from lean. Continuous improvement is self-explanatory. You want to make things better. That's at the end of the day. You want to make things better. You want to make it improve. Continuous improvement is change, but is not the same thing. Change to me is you can have unhealthy change, where it's just, think of it like a river. We can put a dam in a river, and all of a sudden, we're making electricity from that water, we're helping divert the flow, we're controlling the level of the water. Well, say, we could just throw a trench in somewhere and, we can divert the water off that way. Well, now we just changed the whole entire ecosystem, and we don't know how well that's gonna work. We have houses getting flooded, things like that. So continuous improvement is healthy change. It's coordinated. It's thinking it through. With that, there's lean manufacturing, which I'll touch briefly on here, but that's basically my job. Lean manufacturing is, does it add value to your product or process? If it doesn't, it's waste. In lean manufacturing, there's 5S, which this is an awesome little tool. My senior capstone project I said, I think earlier, I don't know if everyone was here, I did that over in that room. My senior capstone project was doing a 5S organization over at Carfair Composites over in, it's just over that way, it's off of like Roosevelt Road. But 5S is an awesome little organizational system. To start, say you got a toolbox, it's got a whole bunch of tools in there. All right, dump the toolbox off. You're going to sort. What do we need? Do we need all these tools? Is there stuff that's just in there? My favorite part is that capstone project that I was part of. We did the same thing. There's the great Carfair Composite makes bus panels out of fiberglass. They had this one area where they polish them up. They had this workbench that was a centralized workbench. And we took all the tools and we said, do you guys need these? And it was funny because there's one, it was basically just like it looked like a ruler, it was just a bar. And it said keep. And we said, do you guys need this? And they said, oh, we need to keep that. It's like, what do you use it for? We saw your process earlier. I don't recall any of you guys using it. Like, if you need it, we'll keep it. They say, oh, we got to keep it because it says keep on it. Do you actually need that? Well, it says keep on it, so we got to keep it. We ended up talking to the supervisor, and he knew exactly what it was for. Someone who's using it as a straight edge, but they got a new, real fancy, like a right angle or a corner that they used all the time. So we took it out. They didn't need it. Sorting is just, what do you need? If in doubt, you take it out. You want only the tools that you will need. Now there is a little bit of a caveat, because sometimes you will have things that are special cases, but you don't want the clutter. That's the main thing of sort. You don't want that extra clutter. If in doubt, you take it out. Set in order. Okay, now you got all the tools that you want to keep. These are all the things you need. Put it back into your toolbox and make an actual spot for it. There's the cutout foam that you see in like a lot of toolboxes. That stuff is awesome. The goal of set in order is that everything has a place and everything should go back to its place. And I was using that example of when we cleaned up the shop and we had scheduled cleanup times. That is more or less for, you put all your tools back, and since every tool has a place, you know what's missing. Hey, we're missing a tool here, the spot's empty. Where is it? Oh, I accidentally had it in my pocket. It saves on both time and money because now you're not looking for stuff. And that leads right into shine. Just keep it clean. Because if you have we've all been there. You have a workspace where it's like you have everything on there, and well, now we have tools here, we have parts of robot here, we got just raw scrap here. Where is everything? Where's this tool? I need this. Where's it at? I'm looking for it. And that leads into, again, the efficiency thing, where now we're wasting time looking for a tool when we could actually be doing the work and getting it done, so that we're not down the road cramming, scrambling, trying to get it done. Standardize is make sure that everyone knows, okay, this is how it should look like when it's clean. Even if you have a picture, like this is prime state, this is what it should look like when it's all cleaned up, ready to go. And then this is what the actual tool layout looks like. And then if someone needs to change something, this is important. Standardize is if someone needs to change something, who do you go to? Hey, we need this new tool. Hey, we need a different fixture for our mill. Well, who do you go to actually get it changed? Because you don't want to get it ordered, and then here now, oh, we don't have a spot for it in the toolbox or in the cabinet, so we'll just throw it on top. Now, does anyone even know that we have that? If it gets lost, it's not part of the system. And then the fifth step is just sustain. You want to keep that process repeating. You want to make sure it's, again, if you have a safety manual, that it's documented somewhere. And this is a great place to put 5S, to put it in that safety manual. And then now, a lot of places are actually trying to add a 6th S, which is safety, where again, you basically, this works really well in a pit, by the way. The robot goes out, okay, let's go vacuum it up, clean it up. Like with standardized, do you have a checklist? We did all that. Okay, now let's look at it safety-wise. Is there anything that, that's spilled? Is there anything that is, we have metal shaving somewhere that we shouldn't? Okay, that'll get cleaned up and shine. That's what we want to look for. And a lot of industries are looking for 6S. And I think I want to open up this for any questions you guys have, anything at all. I mean, and if we don't have questions, I will make questions, so please ask.
How do you implement safety into events that you're running?
Are you talking from my standpoint or from a safety captain standpoint?
More from your standpoint, like for us, we run a league, so we have all of our FTC teams there.
Yep.
What standards should we implement to make sure that they're being safe?
And from an FTC standpoint, from that, do you see anything unsafe? Are there, I know, like, do you have extension cords just all over the place? Is it a tripping hazard? Can those be rerouted or something? Look out for that stuff. If you're going to a venue, before you go there, meet with your team and say, hey, here's where we're going. If there's a hotel, this is the hotel. If we have an emergency place, this is where we're going to be meeting. Here's who we're riding with. Do you know who you're riding with? Do you have a buddy? Again, it's just, you really want to look out for that. And then again, if you have younger people that may be visiting, do you have safety glasses? Do you have enough? Nowadays, they make safety glasses for kids. So if you have like a little toddler, some great big honking safety glasses aren't going to work, when the guy's head is only this big. So they make little safety glasses now. Did that answer your question? Or?
Yeah, that was
okay.
good, thanks.
Okay, anything else? I know that might have been a bit of an overload, but yeah, go ahead.
So you talked about like trailer like packing and stuff like that. How would you sort of learn about and implement that?
Yeah, honestly, if you want to get really into the weeds, I said the load securement expert, he was actually my dad. He works in construction, but he started out as a truck driver. And truck drivers, they have to know DOT, Department of Transport, MnDOT, if you've ever heard of that. You can go on their website, and they've got a lot of resources on there for properly loading up stuff. Because that's a good note. One of my biggest fears at a regional is when there's load in and load out. Because you have basically the trifecta of worst case scenarios. You have, it's normally dark or nighttime. You have people backing up with trailers, and I'll put out, maybe it's a square or something, not a trifecta. But then you have normally people that are fairly inexperienced. Not always, but a lot of times you have people fairly inexperienced with trailers or just backing up with trailers, which if someone's gonna get hurt, that's my biggest fear is in that area. No one has, but it's one of those that's always my nerve-wracking spot. Like at GCR, I normally help out with unload just because it's something that you gotta have a lot of communication. You gotta make sure that people get in smoothly and get out smoothly. So in terms of load securement and just proper loading, MnDOT, DOT, there's a lot of resources online. If you wanna go as far, there's books. Otherwise, if there's anyone on your team that has someone in construction, because they have to know how to load skid steers, loaders, things like that, bulldozers, talk to them. Truck drivers, same thing, they gotta know how to actually load their load. So, yeah, that answer your question?
Yeah, thank you.
Okay. Anything else? Go ahead.
What would you have in like a safety bag or something to go on?
Safe, like a first aid kit, are you saying, or an actual safe bag?
It's like I would assume there's a first aid kit in there.
Yeah, so that's a pretty good question, because yeah, like first aid kit is my first mind, but even in terms of a safety bag, where you go in a step further, I'll put it to you this way, some first aid kits don't have tourniquets. There's honestly, I've never had to use a tourniquet before yet, but even a belt is a good tourniquet in a pinch. But you can actually buy nice tourniquets where it's basically like a ratcheting system where you put it on someone's arm and you twist it and it holds it tight. Tourniquet, just water. I mean, seriously, I'm someone that I have gotten on 2 or 3 occasions very, very dehydrated to the point where it's heat exhaustion. I've had that really bad. And I can tell you it's not fun. So just making sure people are getting stuff to drink. I know, I don't think it was ever in the safety manual, but there's a little while ago where people are kind of arguing, should you have food and drink in the pit? I mean, this is my own personal opinion. I'd say no, there's no rule for it. But the biggest thing I'd say, you should have water. Yeah, I will, any day, I will die on it, that if it's okay to have water in the pit. There's a lot of teams I see where they have, it's like those little caddy things where you can slip water bottles in them. Perfect, that's excellent. I recommend any team to have that. Just because at events especially, I mean, it seems regular in there, even in this, building here. St. Cloud State always seems like it's a bit warm to me. So just making sure you have something to drink. Safety bag, you know, maybe have your safety manual in there, maybe a little first aid kit on top of the first aid kit. If you need emergency contact numbers, if there's something like special medicine that someone may or may not need, that's what I would also maybe include. There's another good one that I had on top of that. If I remember what it was, I'll come back to it. But honestly, if there's anything you think you should need in that safety bag, I'd have it in there. Just make sure you're not lugging around a huge 30-gallon bag or something like that. Just within reason, but a good first aid kit, and it goes a long ways. And I think probably the most incidents we see at regionals is just dehydration. Make sure you're being hydrated. Yeah, emergency contact numbers is a long ways. Just make sure that gets up to date. That's one thing, again, where you want to make sure people safety isn't paperwork, it's not a checklist, it's a culture. Because if you start printing stuff out, the minute you print it out, it can become out of date almost immediately. So you just want to make sure that's all up to date. Yeah, no, there's something really good that I had that made me think of. If I remember it, I'll try and let you know. Any other questions? Anything?
Why'd you get into safety? Like, I'm a marketing guy, I like stories. What got you into it? Because I'm guessing without FIRST, the direction of your career might have gone a different way.
I think, because technically I'm not in safety, I help out with it a lot, I think of it, but if you want specifically of why I got into safety on my team, my friend Evan, who if you go to GCR, he's the tall blonde guy that is my co-manager, and he more or less, we were both in Boy Scouts together, he's like, hey, I'm going to be graduating, you're going to be the next safety guy. That's how I got into it, like honestly. I mean, also my dad, he's in construction, he started out as a truck driver, he got more into the DOT side of things and then became a safety guy. And I knew of policy and things like that. I kind of grown up with that background. I helped haul equipment and stuff like that when working with the land, and with a machining background and a manufacturing background. There's a lot of that because I started out as a press operator, and I can tell you it's injection presses, great big machines. I've almost cut off my finger once because I myself chose to do something not great. So I'm telling you, think things through. Don't try and do things quick. There's a reason. If you want to get real, a lot of safety policy and regulation and rules is written in blood. There's a reason it's there. But to answer your question, more jovial note, yeah, like literally my friend was like, you're going to be the next safety captain. Yeah, I don't know if he put it that bluntly. He's like, you're going to be in robotics come to the next meeting. And I was like, cool. And then he was like, this guy is going to be my replacement here. And I was like, all right. So that's about that. But it's something that I ended up learning about continuous improvement in there. And that's where I got into the manufacturing engineering technology side of things, which they have a program for here at St. Cloud State, which I personally like a lot more than just regular engineering. It's a lot more hands-on. There's still math in it, but it's a lot less. And there's more of the continuous improvement side of things. And I kind of specialize in injection molding and no longer work in that industry, but I still like it. So yeah, it happened to work out that it really went down right path. Anything else? Last minute questions? I am here. That's my email if you want a copy of this. If you want any questions at all, if you want a copy of the safety manuals, even one of the more up-to-date ones, I'm willing to provide that. Otherwise, it looks like it's more or less about time. So I appreciate you guys for coming. Thanks.
Thank you.
Yep. Yeah. Cool. I only have this one right here right now, but if you either, did you write down the email that I had up there? If you send me an email right now, you got a piece of paper, write it down. What's your name?
I'm gonna transfer these into different pieces of paper so I can organize it better. But I have ideas now. I like being very
So it's just the name. just all lowercase. Send me an email, try and do it like today or right now, and I'll make sure to give you some information, okay? And just put in there, just like, hey, could you please send me, safety meetings. Yeah, thanks. I honestly could probably take 3 hours. I always interrupt, but I have to run off real quick. Because all of a sudden it's just like, oh, dang, it's that for some reason we ended at 15, we ended at 11.
We have lunch after this. Come back.
Starbucks you go to now. I went in Glacier North for the law.
Yeah.
I can live without. I didn't take notes because I was like,
You keep getting a million again.
Yes, yeah, you should be able to just plug it in.
I can
You
pick
might have to change from mode on their laptop when you plug it in. Yeah, my laptop. That's
Is it
all
all
because it's not
from,
going to
they
It
all
was.
from one?
That's
Well,
right.
I see.
I'm just gonna put them all up there. So that
What are we doing in the first session? Apparently you were. I suppose if you
What do we
were
do
made
about
that, you and me met with some of the coaches over there. I was back here.
Oh, yeah.
milkshakes are different times.
Oh.
Mhm.
2 hours.
Yeah, no, you and Minnie met literally walked right past us. I didn't see Coach come in though. He might have gotten in first.
Buddy mine's all tilted to rivals.
Also you two got the rest of
Like,
it.
edited because I crossplay.
The one that started that.
Because he's trying to play gold after.
I mean, it's just
Finding
it
people
is
with
just
grandmaster envelopes.
You mean this Friday?
Obviously,
Yeah,
obviously, I haven't been able to.
First game he barely left. The next two he's pretty sure we were all grandmasters, do what to do and how to do it. He wants me to play all that first.
Right. It's fairly stressful.
Tell them
The second More strategy.
Things go right? Oh, you're just not gonna be at, our regional this year.
I think
Oh. I just this morning I went up at
Oh my gosh, she is a potato.
This is a little
Okay, close your mission.
Down here.
Both of my parents were up for some reason, so. Originally, I was just going to my dad, make sure I get on time.
Well, actually, that's one reason I may want to buy the Blues Panther. It's a Star Wars crossover.
I might do
There's a
that. I
film,
might do
there's a
that.
film. It's tight. I think what lightsabers that hit you from the lightsaber. Reflect projectiles.
Yep.
And there is an example on type that gives you block swords.
Oh!
There's an aspect of getting kills with swords. Replenishes your health. And this exotic also gives you 95%.
Oh!
I can Darth Vader and walk into a room and not die. high.
Did you?
That's why I wanted to do this.
Yeah, I'm working on it right now. I think it's really good.
No.
I don't think that should be allowed.
Yeah, it's especially on solar, that's what's cool about it.
I'm so excited to learn.
There's been lots of work on it, different colors of that.
Oh, nice.
Good. It's like you have red one, you have orange one, like your black one, you get a purple one, like it's super cool.
Alright.
Alright, well, looks like everyone's here and we've got time, so we'll get started. My name is Kirsten. This will be my 3rd year on CIS. My prior experience last year, I was like the scoutmaster, so like running all of that for our team. And then I've got a little bit of experience doing match strategy as well. And I'm one of the co-leads of our scouting and strategy department this year.
I'm Emmett. This is my 3rd year on CIS. 2 years ago, I was the scoutmaster, and then last year I was human flanker. That's strategy with the front.
He's the other lead as well, so.
Something that we use on 4607 that I find to be incredibly useful is our scouting app. The scouting app is a resource we code and designed to collect data at a regional to
So basically, we work with our programming team and we just kind of tell them, here's what we want, can you please make it into an app? And they do that for us and help us like update it throughout the season. So it's made in-house, so it's like catered to exactly what we need. And when making the app, it really starts with game breakdown right after kickoff. This is kind of when all of this stuff takes place. Look at the game, analyze it, go through the manual, just kind of look at any possible way to score points. Deep dive into all of that stuff. Look at autos and where you can start, just so you can also collect data for who's compatible with you when it comes to the autonomous period. And then end game as well, trying to figure out, so for example, rescape, can they climb? Is it a deep climb, a shallow climb? Really just trying to collect all the data on these teams to kind of figure out who you're going to mesh well with and what your best pick will be for an alliance selection. Another thing that's good about this app is how accessible it is. Because we make the app, we have it from square one, so like everyone on our team knows all of it. It's good for app training because if there's any bugs as well, we can give it to our programming team and they can fix it up. Having your own is really useful. While like borrowing from people is nice, just to be able to have full access to your app is a luxury. And then you have a scouting app, but you need scouters to be able to use it. So, like I said about app training, that's something that's very important. Don't do it the day of the competition. It's important that everyone on the team knows how to use it for the most efficient data collection. Just take a time, like right before a regional, and we have 6 iPads, 1 for each robot, so I like to take a group of about 6 people and put on like a live stream of a week 0 or something like that, and just kind of have them run through the motions. You don't need to collect any data, but it's important to run a training session like that, just so everyone's on the same page, any questions can be answered, because worst case scenario, you give someone an iPad at a competition, and what are they going to do with it? They don't know how. Then there's rounds of data that you just don't get collected or collected wrong. And no one wants that because that's not useful whatsoever. And on that note with the scouters as well, having some sort of schedule in place, like I have up here. So like, you can't see that it says it, but the bright blue is the scouting time block that we have on this one. And it's just important to have a schedule for them. So then everyone is showing up. You know that you have 6 people in the stands at all times. So no one's having to like double up on iPads or trying to find someone last minute. Just so everything like cycles through efficiently, effectively. And it can also help teach people to be punctual. It's like, well, my shift starts at 11:30. I need to be at the stands at 11:25. And that's another thing that you want to try to drill into their heads is it's okay to be late if you have a very valid reason, but then you need to communicate that. Communication is key with this. And the schedule also just kind of helps to make sure that no one is scouting all day. Because how many people in here have scouted? I expect hands raised. Yup. How many people like it? Alright. Scouting long hours can be pretty boring, pretty taxing as well. You're just sitting there, but like it does mentally take a toll on you, and eventually you're not going to get the right data, and it's not good for anyone. You don't want to be there, and your strategy team doesn't want bad data to look at. So just having a schedule to make sure that your scouters are being relieved every 2-ish hours. That's what we found works for our team in recent years. So just everyone has a place, everyone's in their place at that time. And then also like so people aren't getting double booked on stuff. You don't want to schedule a pit member for scouting and then they don't show up. So just to have this and being able to share it with everyone is a very useful tool while at competitions. And then with that, make sure that you're keeping people in the loop of what's going on. Just again with that communication, none of this is going to work without communication. So whatever channel you use, we use Slack. I don't know how many other people use that, but just being able to reach out to people is very useful at competitions because again, it just makes everything run smoother. Also, on the topic of scouting not being so fun, it's important to tell your scouters why they're there, what they're doing, how it helps, because you could give them an iPad and be like, yeah, watch all these matches for a couple hours and tell me what to do. But if they're not on like the strategy side of anything, that doesn't mean anything to them. So it's important to just kind of show them algorithms that you have, spreadsheets that you have, what you're looking at whenever you're making picks for teams at a competition. Just kind of telling them, because the scouters are kind of the backbone of all of this. If you don't have them, you don't have data. If you don't have data, you're kind of going off of your instincts. That doesn't always work. So just kind of telling them why they're there, what their use is, just kind of like let them know that this isn't busy work, because you want your scouters to be happy. Unhappy scouters is kind of unhappy everything. And numbers can be a struggle on some teams. In recent years, our team had to work with other teams to kind of fill scouting spots. So just being able to kind of reach out to the people in your community is a resource that you should be using. Just reach out, be like, hey, we're going to the same competition. Can you spare a couple people for a few hours? And then in return, if they choose to help you, you should be letting them use your data because it's an incentive for them to help you. And why would you use them if you're not going to reward them in some way? Because like, yeah, they could help you, but unless they have like some sheer kindness out of their heart, like that doesn't mean anything to them. Like it's, oh, we're gonna give you data, we're gonna give you an upper hand. So just make sure if you're going to collaborate with other teams, just kind of give them that incentive, hey, like, you scratch our back, we'll scratch yours. And then in the stands, you should have like a scoutmaster, scouting coordinator. We call it the scoutmaster on our team, just kind of someone up there that's keeping track of all the scouters, all of the iPads, someone there to cover shifts if someone needs to go to the bathroom or just take a walk. and then also someone that can be making sure that all of the data is getting uploaded, because for the strategy people, again, like data is crucial, and if you don't have access to it, like, what are you doing? So it's important to just have someone up there kind of in charge of everything, so it's more controlled chaos instead of just sheer mess. And then make sure you're also keeping your scouters motivated. Like I said, it's not fun. So if you want to have like drinks in the cooler or snacks, or literally just like make sure that they know that you appreciate what they do, that does go a long way. Like, it may not seem like it does, but just kind of showing them that you appreciate what they do, it goes farther than you think. And that's again with that thing of like making your scouters happy, it's kind of good in the long run for everyone. And I think about this one.
For pick room, you wanna just be prepared. For a pick room, it's usually the night before the line selection, unless it's like state or something where it's just the day. Go off the data you've gotten from scouting. Make a top pick list of about, is it 24 teams? And then before pick room, just take a little time to unwind, maybe eat something, calm down, clear your head a little bit, and then go back to training.
When you come in and just kind of like unwind, relax, it's really so that everyone in your pick room is focused on the goal at hand. Like, how many people in here have been in a pick room before? Show of hands, yeah. So, I'm sure at least everyone in here at some point has been a part of a very unproductive pick room. And how does that go? Anyone got anything to say about that? Yeah, I see a lot of, yeah.
Just like, it helps to only have people that are like gonna be making the pick list and stuff, and not like people that are just there for
stars.
Yeah.
So it's like, everyone gets it, like, the days can be long, especially like if you're at like the world championship, like it's a lot of robotics, days get long. So just like taking the time to kind of just chill out after the competition. If you do that, you're gonna see a difference in how it goes.
Have people from multiple areas, like say people from the stands, people in the pit, just to get a different viewpoint. Make sure to have your draft team in there to see who they work best with. Have like draft coach, at least a few mentors in there.
No. Make sure that you also have some sort of goals, processes, some sort of plan in place before you're just gonna go into this. Like for people who have never been in it and they're new, it's important that they know kind of like the structure and what goes on. And if you need to run like a mock pick room before like actual competitions start, just to kind of get a feel for how things are gonna go, it will show just like that everything is more structured. Because again, like you don't want people there just like twiddling their thumbs, not showing any purpose. So just to have everyone on the same page, it does make everything run smoother, because I'm sure like all of you know, like you want to get in and get out with the right choices made. Like you want it to go fast, but you want it to go like efficient. So it's important to just kind of have like some sort of plan in place. And then goals. These are really up to you, customizable anyway. But just kind of taking a look at how your robot functions, what the state of the mechanical side of your team is, and just kind of making like a puzzle with the other robots, seeing who fits the best with you, who can work together. Like, watch old matches and just kind of look at, oh, that match, we put up a lot of points. That was almost a high score match. And then just kind of look, who did you work harmoniously with? Because that's kind of who you're looking for in these pick rooms.
It's important to have like a secluded space, like a conference room or a certain hotel room, usually with a TV or a projector, so you can have everybody looking at the data and just have it more in a meeting format where it's not just one person leading it, but kind of like a roundtable sort of thing.
That goes in with the focus thing. Like, any space that you have access to can work, but we prefer to use a conference room just because it's big enough for all the required people. And then also, you could shut the door and you don't have to worry about taking over like someone's hotel room if you're away. And then like, there's not going to be other people coming in with like, oh, did you see that one thing that happened today? It's like, no, we're not worried about that right now. We're worried about what we're going to do tomorrow during the lineup selection. So just kind of make that focus. And then before the pick room, make sure all of your data is uploaded. You want to be looking at the most current things that are going on. You don't want to make picks off of old data because even though you're making these picks, everyone knows anything could change match by match. So like there's still going to be changes the next day, but just like all of those changes, you want them to be recorded so you're not just making picks off of what happens, say like right before lunch versus like at the end of the day.
You're going to want to take a look at how you've been doing to see if your team is most likely going to get picked. And the next day you should also have somebody going to some of the top teams to advocate for your team.
You want to plan for everything. Plan for things to go wrong. Plan for other people to pick who you want to pick. Plan to be picked. Plan to be in a picking position. You really want to plan for every uncertainty because with this, we're trying to eliminate those uncertainties the next day. Now, alliance selection. This is what everything you're doing in the previous days, that's what it's going towards. All of the scouting, the data collection, this is when these scouters can take a break and when the strategy team really comes in versus the scouting team. So with this, you're going to want to talk to teams beforehand. You made a pick list, but so did everyone else. It's not going to go your way. So to try to convince teams that you're the right pick for teams that like you want to be picked by, talk to them and see where they're at. It's really just getting a feel for what everyone else is doing to, again, eliminate those uncertainties. And then, again, because things change round by round, like be watching scores, like watch the Blue Alliance, upload your data frequently, just so you have tabs on how the day is going.
Also, keep an eye on your top like 10 teams, the people you want to pick, and if they have something go wrong, go check on them. Go try and help them out.
Yeah, just kind of like looking closely at everyone else. Obviously, like, you want to know how you are doing yourself, so you can advocate for yourself, and then just kind of be in the know with your team. But it is important to just like kind of try to see all with everything that's going on. And that really is like with the teams that you deem important with that pick list that you made. You want to really be like honing in that. But then when you're on the field, there's a couple things that you need. Strategy person, a person that's relevant to the situation, whether that be a drive coach, a driver, a programmer to discuss autos like in 2024 Crescendo. Just someone who will aid the situation. It's nice to have another person. If you like to work alone, work alone. but just to have like another person there bouncing ideas off of you when things change, so you're not just kind of coming up with it by yourself. That is helpful. And then make sure you have your data, like your pick list, all of the stuff that you've collected, so you can kind of organize it by, oh, we need an algae bot, well, let's switch it to this and look at these teams versus focusing on a coral bot. Just kind of like making sure that you have all of your data with you so you can look at different values throughout the time. And then when you're up there, make sure that you're taking others' opinions into consideration as well. You don't just want to take over everything yourself, because that's not going to reflect well on you, it's not going to reflect well on the team. And also, like, people have ideas. Like, no one knows their robot best than the people on the team. So you know what you saw, but they're going to know it better than you are. So it's good to, like, ask them questions about how things are going to go. And this is just kind of when, like, that strategy talk, that robot talk comes in. Just make sure that you're not overpowering everything. Now, here's kind of like open discussion. We have some frequently asked questions, but now is a time for questions that people have.
So if we don't have like iPads, like, do you ever have scouters scout with their phones?
Yeah, so part of that accessibility thing, it's easy to share the link to people's phones, like on like a Slack channel. Like on our way down to Worlds last year, we wanted to do free scouting of all the teams that we were with, so we just shared the link to everyone's phones, and they were able to use that along with like the Blue Alliance watching matches. So with making your own scouting app, it is nice to just have like that link ready for people to use.
Just to add on, the app we use is a web app, right? It's not specific per device, so we can work on anything. Anything that has browsers.
Any other questions? So how many people in here are on like a scouting strategy department? Show of hands. Any new people in here? Alright, how about leads, department leads? So what does your department do for the scouting side of things?
So, scouting side of things, we unfortunately do have a smaller team. I believe we're currently at 8 members, so it is a bit like stretched thin with who's in the pit, who's managing media. I have to balance both media and scouting. So, primarily, most of the scouting duties do fall to me. I like to take some of our rookies, teach them how to like field scout and pit scout throughout the day and such, just sort of like initiate it. But overall, I'm most of the times either in the field, doing the scouting myself, where I prioritize, I look at the schedule, see what teams we are playing with and against, we prioritize watching those teams. If the teams that are playing do not contain anyone we will actively be playing with, we tend to go manage other duties and stuff while that match is going on. Other than that, when I need to go handle like media and marketing team stuff, I usually grab one of the rookies, sit them down, teach them how to use like our software I want to watch for, specifically what we need to like handle, what we need to focus on, and then I leave them to their own devices, and I'll come back and pick them up when I am available again.
Okay. Now, with like the scouting, do you guys work with any other teams, or is it just
We primarily stick to our own devices. We did work with you guys, 4607, for a while, but we're starting to pivot to more individuality within our stuff, like compiled with data from specifically our team. So.
You said that you were a department lead as well?
Kind of like strategy a little bit. We didn't really do much scouting. Like last year was like the first year we did scouting.
Yeah, we've had a really small team, so scouting's been like copy and paste your data. That's our scouting department.
It works.
Show of hands, is there many people who have done collaboration with scouting? I know you guys have. Anyone else? You want to talk about those experiences, just scouting with other teams? Does it work for you? Does it not?
From what I remember, I don't remember my team ever actually getting the data or being able to access it. We never got picked, nor were we a captain, so it didn't matter the company opinion. But the actual experience was, I mean, it was fun, it was a good time.
Yeah, having the data like on you, it is another kind of point that you can show whenever you're wanting people to pick you. It's like, well, like I have all of this, it's accurate, and like in instances where the team doesn't have the data, it's nice to just kind of show. Like at state last year, we worked with Nightcrawler and Patriotics, and just being on the field with them and kind of cross-referencing what we have. It's a good tool to have, so then you're kind of getting account for everything that goes on. But then it's also just like a good thing to show.
So you're collecting all your own data from your app, and that's obviously the relevant data from the competition. Are you comparing or sense checking that against other sources like Statistics or stuff like that?
Yeah, so in our pick room, we do use like Statistics, Blue Alliance type of stuff, just kind of to kind of look at what they have. We don't necessarily collect the exact same values because they kind of weigh theirs a bit differently than we do. But then also just being able to use that to kind of look at how the match itself turned out. If it's like a question about a specific match, yeah, we do reference that way. Anything else? All right. If anyone has anything to ask, we'll be right here. Questions, comments, concerns, we'll be here. Thank you for your attention.
Sorry.
Well, I did 7, all 4
Stop whipping them.
That's just like when you're having a serious conversation, and it's just like interest, like on the right one.
Yeah, wait a minute,
No, I can tell. What's the date today?
Oh, 6.
They're complicated.
I scouted just.
Yeah, we got a while till lunch yet. We got another hour. Red line's 12:45. Our lunch starts at 12:45, so we can literally. Yeah, literally. But we can now just kind of walk around and do it as quickly as
I don't know why you want to do this.
And their talk about structure definitely.
We were discussing rivals. They want to know is currently the worst state in the game. He is getting out-healed by the main kills. The only lower output in the game is Ultron. And he just plays the scout on this, and he just like forgets it.
When they had Ultron,
Ultron's been in the game for a couple seasons now.
I need to get that on Ultron.
You probably should. Like, hey, I'll be there if you do.
This year, I guess it depends. Scouting versus strategy. Previously, we've always done scouting.
Later, Daniel. I like your haircut.
Thanks, Big Cat. But, like, you want the main people who are overseeing the collection and the data because they know how to read the data fast. So, but our meeting ends up with, we have
Wait, no, I'm over there.
Both of our drivers,
we're
we had our
Yeah.
driver, backup driver. We had our pit captain, we had coach, we had.
Can't see that. There's gonna be people on the front here.
Someone else, I don't remember. So there's a lot of people trying to say something cut off or spoken over by someone else. So you need to limit it so that you reduce the amount of noise and chatter so you can actually focus on the meeting, but you also need to have enough people that you can actually go through the data in a timely manner and have the relevant viewpoints that you need. So, if there's a delicate balance.
What material is this? What material to make it fully secure?
Yeah, what's that?
Yeah. I'm
Polycarbonate?
running off of some red.
You use, yeah, like printed polycarbonate? I think so, yeah.
We just plug it into this thing and plug it into USB.
Interesting.
That's like mine.
You're in the same one.
Yeah, it is. It was mine.
That's a lot of the parts on the robot were like his own stuff. And it was printed at home.
Some of us have a little financial issues on our team, so they have to use resources.
Oh.
I just like plug it in here.
Never printed a
Because you
piece.
can't print it.
Well, yeah, no, there's no way I don't print that stuff.
Or is it this thing? This one?
Yeah, I think.
Oh, yeah,
That's a charging cord. That's the
Oh, you. I'll plug this in.
You need wiring help?
Wiring. It's my worst nightmare.
Oh, that's all I do.
You're not.
That's what we're looking for.
Wiring
I don't have
batteries.
the port for that, so I just have this USB that has a presentation.
Oh, and then
You should probably just use.
any quick computer, dedicated PC, that's what's the animation PC.
There, it's up there.
Yeah, you just click the computer button.
Oh my god.
And then do stuff.
Yeah, is that you on that? That looks like you.
Very top one.
Look through all of your
On
files.
reset.
Go through a search history.
No, this is like, it should be,
It's on reset. It's very center. No, over.
What?
Top of that one.
no, it's not mine.
Oh.
It's a thing called Amy.
Scroll down.
You called it Amy?
Yeah, perfect.
How do I see what I'm plugging in?
It should just be on there.
Wait. I think you have to plug it into that.
Oh yeah, you have to plug it into the actual like PC, not the.
See if they got fridge in here?
That should show up. Maybe.
Oh, yeah.
Amy's birthday gift pictures.
Let's go through them.
Yeah, let's look.
Let's see them. Let's see them.
Acrobat.
Oh!
Should probably actually update that instead of having Rochester.
Yeah, look, you can just delete the first.
How do you present?
Is there a log key? Hit every button on the keyboard.
There you go.
Full presentation.
You know, I probably should have had it.
You just did.
With my presentation.
What time, but do we have the first lunch?
Setting up.
There's two different lunches, isn't there?
Yeah, we can go to the second lunch.
You can go to either.
Either? Let's go.
You got the white ticket?
I have it. Do you have two?
Sign to the.
I was supposed to freaking get one?
Go get one. Quick. Shoot.
Yeah.
They might not be there. but-
Yeah, they're probably not there anymore.
Yeah, I can get one for you.
Oh, yeah. That's what we're. 12:05, 12:45, 12:45. Does they ever just sit in the, like, law room? Is that like- find the best practice.
We don't have the cool, I added some cool animations, but I don't know how to like play it as a PowerPoint.
Doesn't it just go one by one? Just hit next and it keeps going, or what?
Well, this is just like a PDF, and it's just like going through slides.
Oh, is it actually?
There was like cool like animations.
Oh, we're cooked. You have some really high quality images in there, so.
Good on my MacBook. I don't know.
Do you have to be there the whole time? There's a button thing she had, right? Oh, wait, can I operate the computer actually? Does that be staying here? Yeah, I'll do that.
You just gotta like guess when I'm done. Can we go to the second one? Should you tell Jay?
Were they going to the first one?
Yeah.
No, I still haven't.
No, we should go to the first one.
Yeah, what time is it now?
We should just go right now.
Yeah. Oh, 5. It's 15 minutes. We gotta go pee.
Same.
Wait, wait. We got to go pee.
Because we need to be back here.
Yeah. Well, we usually say you like half an hour. It's a PDF.
It's a PDF.
It?
But we had like animation.
Oh,
I don't know if that works on a PDF.
That's what the file said. It said download it as a PDF.
What?
You signed
Are
it?
you
or-
Silas? Are you Silas?
Am I
Are you
Silas?
the guy who requested
I did.
Yes,
access
this is
to mine?
No, what?
Oh, someone
This is Silas
requested
Roofing.
access for me.
Oh shoot, did I? That sounds like something I would.
Cool. I remember.
Roofing? No. Well, sometimes.
Wow. When it's been.
Did you guys change the HTML? There.
What's this made of?
We have it on there.
What was this made of? I don't know.
PowerPoint. Download it as a PDF. And it doesn't have any.
Oh, you just have it on hard drive.
Well, I have my computer, but it's only USB-C.
What did it do?
That's HDMI.
How did you get yours presentation on there?
On the screen.
I use
uploaded
Joe's laptop.
The HDMI to yours laptop.
Oh, yours.
That's fine, it's over.
Yours might let you use it, won't you? We don't do it for another round. I can go talk to him if you like.
You want the animations?
I haven't even seen them. I have no idea what he's talking.
They were dope.
They were dope.
Well, if it's a PowerPoint, you'll be able to upload the PowerPoint to it. If you send it, because then it would be on the CIS account.
This'll work.
Oh, that works.
I was holding it upside down. The down button does make it go.
Yeah.
Oh wait, I'm going the wrong way. What the heck? Sorry to like spoil your.
That was gonna be a lit presentation. Interesting.
Light.
Light. I think we're too old for this line.
We gotta give people lunch tickets.
Are you gonna go eat lunch now?
Guess one of the team members.
No.
Guess one of the teams I criticizing
What?
they can do better. Guess Ed.
Mr. 54?
That's what I mean.
1322?
My
own
presentations.
6147?
Talk
Talk about.
No, I don't.
Oh my goodness.
I got mine.
The Mary Binary?
Yeah.
What about 4607?
Yes, I got a lot of. That's got a lot more slides.
Ours for yours for what?
Okay, we should go. iPad shirt. Is this like?
Yeah.
Oh my gosh.
What you could improve.
Oh.
I did something everyone.
Oh, is that your presentation?
Yes.
Oh, is that at the same time as ours?
Yeah.
Where was that? You get a ticket?
Yes.
Yeah.
You go to my.
Oh, that's you?
I'm curious how much the delay is.
Hold on. Okay. You're gonna walk in front of it. It's stuck on the floor.
Pretty typical.
Yeah, it's still working. So.
Do you like this? Did you see what I did?
Yeah. It's so lame.
I mean, it works really well.
It's a wireless Unify camera. And these support running Ethernet through USB connected to it.
Mm-hmm.
So instead of Wi-Fi, it's on that, going to a dock.
Hello.
I'm showing you my terrible setup.
Yeah, look at that.
It works though, doesn't
Just
it?
wrap it around the.
Yeah.
Is it not functioning?
Maybe.
They can all hear me talking about how functional it is right now.
We got Dylan, which one's Dylan in?
Next door.
Okay, I told him I'm gonna harass him.
But yeah, it's set up like a laptop right now. So it's got like a little dock and a USB
You
Ethernet.
guys got tickets for lunch?
Yeah. Yeah.
Good.
We're waiting for the crowd to get down a little.
Yeah, we're gonna go. Alex went over there.
Jeez, you got 100 of them.
God, you're gonna eat so much
In
today.
case someone else doesn't have a ticket, which we already had a couple. Do you get, Mitchell, you got a ticket then? You got one, Chris, right? Someone grab one for you.
live like across the street.
like crank up or something, that's like not a good idea.
Not gonna go over yourself. They're like saying they got our list.
Some bias. Oh no. That's so fun.
There's a bubbler out there as well.
So I'm blowing my shit off. Oh, does microphone work?
No way.
Yo.
Yo.
But it actually does? Yeah, it does. Should I like walk around with it?
Yes.
Is it Bluetooth or?
No, it's wired.
Wait, is this yours, Daniel?
I'll put my phone.
There's no camera in here. I don't think we're being recorded.
No, we aren't.
Yeah, there is.
Where?
Oh, there is.
Oh, no, oh, no, it's because it's live streaming. So if you're behind there, they can't see you.
We just cover it.
Keep over.
Hunger Games. Why'd you add in the bubbler?
It's got like not. We gotta like interact with the group, so.
Are we making a bubbler part of it? Is like.
Yeah, I can pass these around. Pass around the group.
Is like the bubbler a part of it?
I don't think we want to do this line.
Are we including the bubbler?
Yep.
We can start. So like dry run.
Dry run, okay. Hello?
Hello. You got this thing. Hello, hello.
Brad.
Brad. No, I don't want this one. Give me this one.
All right.
She was
I
doing
got
it.
the projector. Dude, the laser. Head's gonna be shaking though. As you can see.
Hope that there's not too many adults.
Wait,
Except for,
we're,
like,
okay,
adults
it's
I don't
not, I
know.
don't think it would be the projector, maybe it's by the computer, I don't know.
Wasn't she using it?
It's like frozen.
Well, it's not frozen because I can see the mouse moving. Hold up, move the mouse down, oh, there you go.
That was.
Oh, that was you, so move the mouse to the,
So I can on with this?
okay. Move the mouse.
Interesting.
Is this a Google slide?
Oh,
or
is the
is this-
USB from this plugged in? Oh, no.
That's for sure.
That sounds weird.
Oh, guys, there's the mystery group on this one
Definitely not
here.
separate. I'm not sure they're dating either though.
So that's what are you doing?
You're about to get run over. Oh my gosh. Oh my gosh. Okay, good.
Okay, there we go.
Yeah. Poggers.
Okay, down is forward.
All right, start off with introductions.
Okay, guys, welcome to the
What's up, guys?
CAD best practices in the Jumpstart training. I'm Daniel Leiter. I'm the co-captain of FRC 4728. I'm also the CAD lead, as well as the strategy and CNC machining lead. This is my co-presenter, Silas Rupee.
I'm Silas. Yep.
Yeah.
What do I say?
Silas.
I'm Silas. I'm a mentor on the team.
Strategy lead.
Strategy lead.
I don't get picked.
This is my 7th season in FRC.
Oh gosh, yeah. I'm a sophomore, my 3rd season. And we are from Team 4728, Recording Robotics, formerly known as Recording Rocketeers.
Yeah.
And this is like the same slide, I don't even know how to put it. Our contact information, if you have any questions about Onshape or CAD.
We just start on this
FRC.
one. Oh, no, we have to start on the other one.
contact information is frc4728@gmail.com if you ever need to get a hold of us. Some references that we use to make this PowerPoint, this presentation, frcdesign.org, and Onshape Best Practices for FRC by Drew B. Yeah. In this presentation, we'll go over a CAD overview, Onshape workflow, so folders, part studios, and assemblies. Designing for manufacturing, I like to say don't CAD to CAD, CAD to build. We'll go over that later. Some advanced CAD techniques, and at the very end, we will go over some questions.
I have a question. When have you ever said don't CAD to CAD?
Don't CAD to CAD, yeah, this is the first time. I made that up when I was making that. Isn't that good though?
Silas, you're just
CAD to build.
Silas, you're just gonna be laughing in the corner the whole time.
Hopefully we're gonna have like a...
You want me to do that whole part?
Yeah, you're good.
And the next part too. If you have any questions or comments
I
on
haven't
any
seen
certain
that.
slides, feel free to raise your hand. Otherwise, there's a designated time for questions at the end. So we're not CAD professionals, but we're gonna try to teach you as much as we know. You can't see that though. No, it seems like we don't know anything. I just won't say anything.
Well, or it'd be like, if you
Just
have
say
anything
we're
to
gonna
add,
teach
please
you the
don't be
basics
afraid.
about
Raise your hand.
CAD.
Yeah, if you have anything to add, please raise your hand. Okay, now for the CAD overview. This is going to give you a general outline of what CAD software we use and things to get ready for the 2026 season. First of all, make CAD fun. You can't laugh. Don't look at me, okay? If you look at me, I'll start laughing. Make CAD fun. So I truly believe that the more fun you have with CAD, the easier it will be. You cannot force your students to do CAD. Like after a 5-hour practice, you go home. Students that don't like CAD aren't going to do CAD for another 2 hours. But dedicated students that have fun might do CAD for another 2 hours. And that's how you really get stuff done is at home. So I really think CAD can help your team succeed. So do you want to go over this one or this one? I think I've been talking for a while.
Yeah, I could.
This one or this one?
Wait, so go back here. I guess I can do this one. I gotta like start there.
Where's the thing for this? Do I point out the projector?
I don't
It's
think
probably
it
the
really
computer. It's probably
matters.
the
I don't think it
computer,
really matters.
Oh yeah. Okay, what do you want to do?
Wait, keep going through it.
Why CAD?
We could like split this page up. So you can start, because you've been talking the whole time.
You're just gonna be sitting there laughing the whole
No, I'll
time.
just say like,
Talking.
I'll hand it over to Silas to talk about why you should do CAD. And then go from there.
I can just like take over. We'll see the side. Like why CAD? Iteration, test, and then modify designs faster. It allows you to go back after you've already machined something and change it.
Not machine manufacturing.
Manufacture. Manufacturing accuracy and consistency. It allows you greater control of the manufacturing process.
People walking by are like, wow, they got a big crowd in here. It's like giving a presentation to 2 people.
Weight management. You can track the weight while you design the robot, while you CAD the robot. Communication. It allows teammates to communicate and visualize the end result.
You gotta like say
Yeah,
like,
there's probably
I think
more
about
here.
that.
There's more here. But what do I say?
Like read this and then say like another sentence.
I'd say like a story. I'd be like, for us personally, one of the biggest like driving factors for us getting into CAD was we bought a CNC machine because we need CAD to use the CNC.
Do like Becker did, where they have the bullet points, but then you talk more about it.
Yeah. I don't know, like weight management, like how often are you guys overweight?
Yeah, that's good though, asking the crowd stuff. Because that really allows the presentation to slow down. And
Like, how often have you guys had to start drilling holes in the bottom of your robot, in the belly pan? Because like, maybe you don't have to do that with CAD.
Is your robot chunky?
We got some big old robots here.
Okay, so you do this page, right?
Yeah.
Or you do this page.
It's kind of the same thing.
This is going more in depth from this.
I guess you could do this.
So this is like specific
You can
things
do this
that
one
you
if
make.
you want.
Okay.
Yeah.
So what can you do with good CAD? What do I mean by good CAD? Not bad CAD.
I could pitch
performance.
it too. Like, while you're talking, like I could have like a story, like anecdote, and you can do the same.
What?
Like custom gearboxes. Yeah, we actually used two custom gearboxes on our robot this year. Won't have to do that now that we have cycloidals, but.
Is that like bragging though? Like, we want to say a lot about our team.
Well, probably like stories. Maybe not like bragging about what we've done, but like
things that will add to the presentation.
Yeah, applying things that apply.
Okay. The essence of CAD is to elevate your robot's performance, rigidity, and consistency. You can do that by tracking your robot weight throughout the season. So seeing how close you are to the max weight, how much you have left to add things on. Center of mass calculations. This is great for if you're planning to do like an end game climb, or you're seeing how tippy your robot will be with like an elevator up. You can generate manufacturing files. This is great for 3D printing, CNC machining, even lathe machining. Custom gearboxes. This is great for gearboxes that are not custom. Planned motion mechanisms. This is great for seeing how things fit inside of your robot, so how different components come together. Chain and belt distance calculating. This is great for
You can't
my
use
train
that
of thought
there.
Chain and belt distance calculating. You can't really do this without CAD because otherwise you're just guessing and you'll have sloppy pulleys and stuff. And then finally, render robot images. This can be great for getting sponsorships, putting your robot on t-shirts or on banners. Yeah. Alex, do you have anything to add to this?
You don't have to ask me. I'll just get like, I'll just like jump in. And boom, our robot.
See, it's supposed to be like our robot and then grayed up, like animations. And then like this one, it was gonna be like fusion and then.
Oh.
I spent a lot of time on that.
This is
okay?
all your slide. Okay, go back to
Why
that.
didn't you do that,
Yeah, that's good.
Daniel?
I'll totally remember it. And now introducing our 2025 FRC robot, Grey Duck. Grey Duck was designed using, and I'll say that later. This is our robot from 2025, Grey Duck. As you can see, it has a little bit different manipulator. That was an off-season project that we did. Yeah, we'll use Grey Duck for some examples later in the presentation. Then do you want me to talk about all the on-shape stuff, this stuff? These 3 slides?
Well, we can probably do it together. Like mostly you lead, but I'll.
Okay. Starting off, which CAD software should you use? There are many CAD softwares out here, as you can see, and teams use many different ones. But there's some that stand out from the rest. We're going to use a car analogy to explain these. Fusion 360, we use this for CAM, and this is the second CAD software that I've started learning. So it might be a little biased, but I think it's kind of hard to learn, and it still does CAD, it still drives, but it's not the easiest for new people to learn. Onshape is a bust because you can fit the whole team and they can all work together. We use Onshape for our CAD in 2025, and we are going to continue using it throughout our history, throughout our seasons. SolidWorks is not something you drive to work, but is more of an industrial use. And Blender, I just thought that would be funny.
Why wouldn't you do like an actual industrial thing then?
Well, yeah, I know a lot of industries use SolidWorks, and if there's some like adults in here who use SolidWorks, and they're like.
That's what I'm saying. It's not the best. It's hard to learn. It's really good. It's not the best for like driving to work. It's not the best for first robotics.
Then you should have done like the supercar. It's like a Porsche.
There'll be a time for questions at the end.
That's not a question. Let's see.
Let's bring it back to the presentation. We use SolidWorks 2024 and past.
Yeah.
Literally. Blender. It's not really the same thing. I just thought it would be funny. Blender. If you use Blender, I will personally laugh at you. It is an organic modeling software. Not great for building robots. Okay, Onshape what are some of the things that are better compared to other CAD platforms? It is, see that I was going to do like Onshape, and these things would pop up as I click. It is web-based, so you can do it.
Daniel, why didn't you do that?
It is, yeah. It's a PDF, so I can't.
Oh, wait, why do you save it as a PDF?
That's what they said. They said send a PDF to this. It is web-based, so you can work on any device as long as it has access to the internet, even a phone. Real-time collaboration, so if you have students working on CAD at home, say Silas is at his house, I'm at my house, we can be working the same document and actually see what we are doing and then follow along with each other, and it will update live. It's easy to learn. We have a lot of new students that have picked it up pretty fast, and it's free.
Yeah, there's a lot of resources outside of Minnesota, specifically on Onshape for FRC. It's not specifically us. It's kind of the main CAD software for FRISC Robotics.
Yeah, I suggest use Onshape. The rest of the presentation will be about Onshape. Got me there.
Preseason setup. Do this before kickoff. You can go through it. Because I have like no experience with that.
Okay, I'll do this. Okay, some preseason setup. We all know how busy we're practicing. We all know how busy January 10th can get kickoff. So here are a couple things you want to do before that to prepare yourself. First of all, make an educator account. This can be, I don't even know. Just through Onshape.
Yeah, Google that. Good luck. But I don't know.
You just sign up. When you sign up for Onshape, select the educator account.
There's a difference between classroom and team also.
Teams come from the classroom, don't they? In a classroom, you can have teams, and the whole thing is the classroom.
I don't remember how, yes, one way or the other, I don't remember which one's which, but it makes sense. I'm using it one way, and then I realized partway in the class, I'm like, I never set them up as one of them.
Yeah, I know we set up ours wrong for FRISC Robotics when you're supposed to add everybody to the team and then add the team to the classroom. We just added everybody to the classroom, but then certain people, anybody that's not an admin can't access the documents.
Mm-hmm.
So then, yeah, I added everybody to the team.
I know you fixed it this year.
Yeah, so now everybody can see the documents. And then along with the educator account, you'll get a classroom. We'll go over how to set up the documents for that later. And then create basic folder organization. We will also go through this later. What is the best organization system? Get every student the FRC Design app. This was previously MKCAD. I think it's pretty much the same as MKCAD, maybe a little bit better. I just look up FRC Design app.
Yeah, it's on the Onshape. It's like the Onshape App Store or something.
And then create a CAD messaging group. We use Band and GroupMe for this. Yeah, whatever works for you guys, just to communicate your CAD ideas outside of your main groups. Do you want to go with this one?
CAD schedule. Find what works best for your team. Do as much CAD outside of shop time as your students are willing to do. How do I do it without like when you wrote these, you had something in mind that you were going to say, and that's the same thing that I did later. Like, because I just gotta like read it off and then think.
Well, find what works best for your team. This is like how many members you have, what the dedication level of your members are, what your
Oh yeah, find what works best for your team. It's not a one-size-fits-all solution. Everything in here is more of a suggestion, not necessarily a rule book. Do as much CAD outside of your shop time as your students are willing to do. A large portion of our CAD gets done at home, and it's kind of hard to do everything in the shop, especially when we're only meeting like 3 days a week.
And that's where your collaboration comes in through on.
Yeah.
Tied back to that.
It's a lot easier to do at home when everyone can see it. Our schedule, we have Monday evening CAD calls, get CAD/CAM ready for manufacturing and prototyping later in the week. We also do a lot of it in person too. I think that helps with collaboration, especially when you're able to talk to people. And our goal, our like target this season, is to finalize 80% of the CAD by the end of week 2.
So we can start manufacturing and.
Would you say that's your final, or is that your final for the first prototype?
Oh, the robot, like 80% of the robot's done.
Oh, okay.
I know in history, by the end of week 2, we're still like arguing on what the concept is. But it's less than shooting games.
Well, last year, 80% probably would have been close to what we had. We just didn't have the climber.
Really?
And or no, was that close to week 3?
I feel like, yeah, we were like by week 4, we were
I know we
still
switched
adding.
designs entirely. We had the one, and then you came up with the other one that we just switched to.
Oh, shoot. We haven't started yet. Oh, wait, what are we doing? Wait.
You guys can just keep going. No one cares.
Sure, they're gonna see it twice then.
1:30? Oh, yeah, so we started 9 minutes here. Okay.
Let's go over it quickly. You're gonna read this one.
Yep.
And then.
Yeah, we can probably
I'll
do
read
all
this
of them.
Yeah.
Yeah.
So then you do a lot of this.
Yeah.
I'll do a lot of this.
Good stuff.
And then I'll do this one. And then I'll do this one.
Yeah, I'll like jump in. You'll do most of it though, I think.
Here's a question.
Okay, I want, like what you guys just said, that you made the multiple slides, right? When you were adding stuff to it, right?
Yeah, pretty much.
I want you to do this, where the person, you would like ask you a question.
Oh, yeah.
You know, that helps.
Yeah, if I like
I'm
bounce
saying-
questions off you.
Like instead of you doing it up, you can feed him.
I'll-
That works really well. I just watched it work really good.
Right. No, we're good. We're good now, pretty well. Wait, what's our plan with these? When do we pass
For
through
the
the
manufacturing.
manufacturing at the end?
So art lightning.
Yeah.
Future scripts. Printing.
That's a future script too.
Motivation. Blade. We'd have like a party.
We could have like that, like a challenge. Whoever gives us the most money, we get.
Oh, I need that later.
You need it later.
Huh?
We got like
There's a picture on it? There is for the next session.
The fifth one or the fourth?
For the 5th one.
We did all, we melted all in first and then used put some in the break. Remember, I think that's what we did those on.
Yeah.
We're doing that next week. But I think we need material.
Do we have it?
So the gallery, there's the gallery, is that the main?
But no, you can bend it by hand. Material.
Yeah. We don't have the strips. Did we bring the strip?
Yeah, it is.
We did.
We stole it.
Yeah.
So I think if we use PVC foam core instead of polycarbonate.
What?
Apparently for coral shields or
We-
game piece shields,
Sorry, you got that 3D printer.
it's
Oh, yeah.
lighter
And I have
and then it's not as strong as polycarbonate, but you don't really need it that strong.
I don't think I've heard of that.
Yeah, so when you think about
Some of that
it,
is
so this is wedge that's snap in half. So I had.
It's like the white stuff, though, anyways.
You're right. Fix the chippers.
Yeah.
Pay for the old machinery.
You know, I was getting ready to take them apart and throw them away.
So it's the center of a coral.
Yeah,
Well,
so the outside is all.
didn't they have issues with that?
Good job too. So
They
we
have
took,
issues with that on.
It's
It's
like a
the
foam
third
board,
iteration.
but it's like plastic.
where everything finally lined up right.
Oh, yeah, we were solid and they were.
No problem, you know, you print one that doesn't fit, it's like, oh, that was 5 cents.
Well, I mean, the holes were just, you know, the weird, they didn't line up. Okay, well.
Lighter and it bends
Adjust that,
easier.
print another one.
That like easier bending.
And so this, if it's has moisture in it, and then it creates the bubbles when you try to heat it up
Yeah.
a bit.
We should set ours up with the best.
don't know what that is,
Distributed,
though.
that like.
Reason that sometimes you can't bend it by hand, as soon as you can bend it by hand, there's bubbles.
So let's set that in for, we're going to heater in that whole rig. Like integrate the heater inside of the rig. Like
5 minutes.
just, that's a side note from what you're doing.
And it's just solid white, so you get the spot.
Interesting. Like OP.
Yep.
So, I think this morning, Mr. Wasowski is a Formula One fan. We had a whole table full of people watching the qualifying while we were waiting for all this to start this morning. Max, Cole, followed by Lando and Oscar. See, you know, wake up in the morning and you'll watch a race with me. 4 minutes.
What is also the drive team?
He's gonna try and get off on my start and then end up racing my
He's really good.
We get some music, Daniel, some background music.
So I can see him.
Like elevator.
Trying to take it easy.
Actually,
so I
what
can
to
see
do with that.
Oscar trying to jump.
Get a paint first, right? Get it out or just anything. It's like super fun. It gets like so fun.
They're gonna sit down with Oscar today.
Maybe get some surround sound. You put your phone there, I'll put it in the other room.
Especially not in the turn one where he got red last year.
You could practice it and then have it secured, so we would switch. Substitute.
Oh, yeah.
Oh.
Basically, 16 points ahead of the top.
How to like pick your drive team?
Oh, wasn't that by?
Was it? Watch the video.
No, you're awesome. It's like that someone. You guys hear music?
Jacob with us too.
Probably watching.
I don't know why that is. Boy.
Okay, should we get started? A couple more minutes. Okay, we're gonna get started here. This is the CAD Best Practices class. I'm Daniel Leiter. I'm the co-captain of FRC 4728. I'm also the strategy lead, CAD lead, and CNC manufacturing lead.
I'm Silas. I'm a mentor on the team. I do mostly CAD and strategy. This will be my 7th season in FRC.
And we are Team 4728 Recorded Robotics, previously known as Recorded Ratcheteers. We are now not the Ratcheteers, but just the robotics. Our contact information, frc4728@gmail.com. If you have any questions about CAD, we can maybe help answer them. Yeah. Our references, some things we use to make this presentation include frcdesign.org and Onshape Best Practices for FRC by Drew B. Okay, so in this class, we'll do a CAD overview, just generally how to use CAD, and then we'll go to the Onshape workflow, so folders, parts, videos, and assemblies. And then after that, we'll go to designing for manufacturing. I like to say, don't CAD to CAD, CAD to build. We'll go over that later. And then advanced CAD techniques, some more advanced things for people that may know a little bit more in this class. We kind of want to cover all skill sets here. So whether you're really new to CAD or have been doing CAD for a little bit, hopefully there's something from this presentation that you'll be able to take away. And at the very end, we'll have some questions. And if you have any questions or comments relating to certain slides, feel free to raise your hand. Otherwise, there's a designated time for questions at the end. So this is kind of also like a round table. Like we want to know your ideas on things as well. So if you think you have something to add to certain slides, feel free to raise your hand and we'll call on you. Okay, starting off with the CAD overview. You got to make CAD fun. So it really helps when you have fun doing anything. You're going to learn more. You're going to do it more. If you try to force a student to do CAD, they're probably not going to have as much fun with it, and therefore they aren't going to do it at home. They aren't going to do it outside of robotics. And when they leave robotics, when they graduate, they may not do it in industry or after that. So you really want to make sure they're having a good time with CAD, they're not having any problems, and help them as much as possible. So why should you do CAD? Silas, do you want to talk a little bit about this?
Yeah, so CAD's helpful for a lot of different things. Iteration, test and modify designs faster. So if you have a design CADed, you can like machine that, and then if it's wrong, you can go back and machine the exact same thing again, or modify that specific design, so you know exactly what went wrong. As opposed to if you're just machining something, it might be hard to replicate that very well. Manufacturing accuracy and consistency. If you have a CNC, for the most part, you can accurately make the same part over and over again. Whereas if you're just like freehanding it, it might be a different part, not square, a whole bunch of different things. Me. Weight management. Who here has gone to a regional with a robot that is overweight?
You've almost been overweight.
Okay, so a couple people.
Couple people? Yeah, but who here has drilled those cheese holes in your robot? Who's done that? Is that fun?
No.
Okay.
It was that stage. Yeah, it was.
I have a Swiss cheese robot. CAD helps a lot with that. You can design in like lightening, you can design in and track the weight. If you're overweight, you can like reduce things on the robot. You can cut things off before it gets to the final picture, before you machine the robot and get it done. And communication allows teammates to communicate and visualize the result. That one's pretty important too. It helps keep everyone on the same page so everyone knows what they're doing. If you're able to like see the final result before you actually build it.
Yep. And then here is some specific examples of things you can do with CAD. So you can elevate robot's performance, rigidity, and consistency. There is like the essence of why you do CAD in one sentence. Some specific things, you can track your robot weight, like Silas was saying, to make sure you're not overweight by the time you go into an event. You can make center of mass calculations. This is great for if you're climbing or have a big elevator that may make your robot tippy. You can see where the center of weight is on your robot based on all the things that you CAD. You can generate manufacturing files. This is great for 3D printing and CNC machining. You can't do that unless you have a CAD file to give those machines. Custom gearboxes. We built 2 custom gearboxes last year. They really help for having custom gear ratios. So if you were using like a Max Planetary or something, you may only have a couple gear ratios you can use. So making your own gearboxes is really helpful. Plan motion of mechanisms. So seeing how the entire robot fits together, make sure nothing is hitting. See where manipulators go. Chain and belt distance calculating. you can't really do this without CAD, otherwise you're just guessing the distance. So this can help with like slack pulleys and stuff. And then render robot images. This is really fun for marketing. You can put your robot on t-shirts, in sponsorship like presentations and stuff. And then introducing our 2025 robot, Grey Duck. As you can see, the manipulator may look a little bit different than you've seen. That was an off-season project that we did. But we'll be using Grey Duck for some examples later in the presentation. So which CAD software should you use? Whether you're using a CAD software or your team has never touched CAD, I think there's some things in this that'll help you either change your CAD software or start using a CAD software. There's a lot of different softwares you can use. I know a lot of teams use a lot of different ones. Here's a car analogy to help a little bit. So this is from mostly my opinion. I started out with Fusion, after Tinkercad. So personally, I think it was a little hard to learn. And it still does CAD, it still drives. But I would prefer Onshape. Onshape is what our team uses, or has used in 2025. It's a bust because you can fit the whole team on it and you can all collaborate. We'll go over that in a little bit. SolidWorks, this is what we used 2024 and past. So we have used that one. It's really good CAD software, but it's not necessarily something you would drive to work. So it's more for industrial uses. But if you have people that know how to use SolidWorks, it is a very good option. And then Blender, it's not really the same thing. I just kind of thought it'd be funny to put on there. Yeah, question?
You gotta add fire to the flame. Then it'll be true.
Yeah, don't use Blender.
And
I just thought this would be
the
funny.
crash
It's more for organic modeling, not building robots. So I'm going to try to convince you to use Onshape now. I think Onshape is great, and I think a lot of FRC teams can agree. First of all, it's web-based, so you can go on Onshape on any device, even your phone. You can't really do CAD on your phone, but you can at least look at the document. It's great for if you have like team computers, but then students go home and they have their own computers they want to work on. A real-time collaboration, this is great. So if me and Silas we're at separate places, we were each at our house or something, we can both hop on Onshape and see what the other person is doing while we're CADing, and then we can actually follow each other along. So it'll like share his screen to me and like about what he's CADing.
Yeah, another big thing about Onshape, a lot of other FRC teams have also adopted it. It's kind of become the CAD software of FRC. You'll see every team, like a bunch of teams in California, a bunch of teams everywhere else, and there's a bunch of good resources online specifically for Onshape for FRC, which is one of the biggest reasons we chose to use it too.
Yep. It's easy to learn. We have a lot of new members that we've taught Onshape. It seems like they pick it up very quickly. And it's also free with a student and educator plan. So we'll be, the example we'll use Onshape later in the presentation, because this is the CAD software we use and we think is best if other teams start using CAD. So do you want to talk about the preseason setup?
Yeah, so for the preseason setup, I do this before at the start of the season, obviously. Make an educator account. Dale knows more about that than I do. Some of the
Yeah, you just kind of, when you're signing up for an account, you can choose, I think, personal use, like work use, educator, and student. So just make sure at least one person on your team has an educator account. This will allow you to make a classroom. That's the next one, set up a classroom for your team. A classroom enables everyone on your team to be in kind of one organized Onshape place. So you can have folders there, you can put documents, you can add teams, and then create basic folder organization. We'll go through this a little bit later, but just make sure you have folders set up before the season starts so it's less to do on January 10th. MKCAD or FRC Design app, make sure every student has that downloaded on Onshape. So it was previously MKCAD. Just over the summer, I think, it turned into FRC Design app. It's pretty much the same thing. It's a little bit updated, I've heard. But I think you just look up FRC Design app. There should be a app you can download.
Like the Onshape App Store or something. You can get that from there.
Yep. And then create a CAD messaging group. We use BAM. Just have some group that you can talk about what's going on in your CAD outside of like your main group.
And each student sets up a educator account, right?
Oh, well, the students can get the student account. We just need at least one educator account.
One educator, but then a student account, right? Yes.
Yes, all other students that sign up for Onshape can use a student account.
But they still have to go on Onshape and register, right?
Yeah. And then the educator account can add the students to their classroom.
Okay, so our CAD schedule. Find what works best for your team. This is not a one-size-fits-all solution. This is just what we do. What you do might be different and probably works better for you. Do as much CAD outside of your shop time as your students are willing to do. That's really important. The amount of time you have like in your build space is like super limited. Am I supposed to be louder? No, we don't have a mic.
Music going on in here?
Oh yeah, that's him.
Okay, sorry, I thought they were just piping somebody.
Yeah.
Yeah, this is really important because as many like dedicated students as you have that want to do CAD outside of robotics, that is like absolutely fantastic because the more stuff you get done outside of shop time, the more you can do heading into shop time. So if you get stuff ready to manufacture, then you can be more productive in the limited shop time that you have.
Yeah, a large portion of our CAD last year was done from like someone's house, from online, not necessarily in the shop. Our schedule. So we have Monday evening CAD calls. All the CAD students and mentors come in. We make a call on GroupMe. We all talk about the CAD together, work together on that. Get CAD and CAM ready for manufacturing and prototyping later in the week. That's mostly what we do Monday. Make sure we get it like cammed up, CAD'd up, ready to machine, so then when we are actually in the shop, we're able to machine it right away. We don't have to spend that extra time there. And this is more of a goal for this season for us. Finalize design and CAD, like 80% of our CAD by the end of week 2. Sometimes we lag behind on that. Sometimes we're like doing CAD in like week 3 of the competition season or something like that. But for the most part, we're trying to get most of it done early on as opposed to right before competition.
And this is also goes along with having fun with CAD. So the more you have fun, the more motivation you have to do CAD, and then the more students are going to do it at home. Question?
I'm just curious, how big is your CAD team?
Last year we had me and pretty much one other guy.
It's probably like
did a lot of it.
Okay, like 5. Like this year it's probably gonna be larger. We have like 3 specific CAD mentors and as many students as we can get involved as possible. So hopefully upwards of 10 students. Probably not going to be that many. Probably just going to be whoever's able to do it. But
a lot of those students are rookies, so they'll be still learning. Maybe they'll only have a handful of students that actually know CAD enough to teach those other students. And then practice is great, so as much time as you can get on Onshape, the better. Some ways to get practice. A great resource is the WCP CAD-a-thon. This just ended a little bit ago, but it's basically you design and CAD a robot for a mock FRC game. So basically, they'll release a game manual and a field, and like the field elements and stuff, and you got to design a robot for that game. If you want to do it, you can just search WCP CAD-a-thon on Chief Delphi. The prize portion of it is over, so they do like judging and stuff, but you can still look at the game and still make a robot for it if you want to practice. This is our robot that we designed. Some other resources, frcdesign.org. This is like a spectacular resource. It has basically everything you could want about designing for FRC, so make sure to read those. And then Onshape tutorials. This is by Onshape, just how to use the platform.
And then Onshape workflow and organization. So in general, you have your documents, then you have the assemblies, and then you have the part studios for those assemblies. And assemblies use mates to define relationships and features between moving parts. Yeah, assembly is kind of where you're putting everything together. You're taking things from the part studio, defining the degrees of freedom between them using the mates. You test motion, make sure things are hitting in there. That's pretty important for your assemblies. If things are hitting, it's not going to work very well. And then, wait, no, go back. And then Part Studio, use sketches and features to create parts. Keep features less than 250. Some of these really big Part Studios get hard to load. Everything gets slow. And keep parts less than 20. Sometimes these things can get like hard to organize. If it's just like your entire robot in one Part Studio, that gets to be a pretty big headache, and your computer is not going to like that.
Yep. So basically, you create the parts in the Part Studio and assemble the parts in the assembly.
So document organization. This was a screenshot taken from Buck's Wrath. They're a pretty good CAD team. They're a really good team from New England. So you have your master document. You can put your layout sketch in there. Some teams have a layout document as well, separate from the master document, but you can go in the master document, that's fine. And your main assembly, that's where you put everything together from the sub-assemblies. You want one document from each subsystem. So you can see here they have a drivetrain, shooter, superstructure, and their intake. I think we had like 6 or 7 of those this year. You have more than that. You can get like tons of these in there, but probably want to keep it down. Maybe start merging some of your subsystems together if you have like 15 subsystems. Kind of a lot. Make sure everyone is familiar with the desired setup. What kind of sucks is if you just see random files start popping up in there. Like someone's like remote folder, I think ended up in our main Michael's remote folder. In the preseason, make sure everyone knows what you want this to look like, so you're not having like random folders everywhere. I think that's pretty important.
Yep. And make sure everyone understands, like, if you add these numbers, like, just make sure everyone knows what the numbers mean. I think, personally, the numbers are kind of confusing. We just like putting drivetrain, shooter, superstructure, but just do whatever works best for your team.
Yeah. And then Part Studio organization. Again, 2 screenshots taken. So for Onshape, you can create folders, and you can put different like features in there. You can put your sketches, put your extrudes in each one, and you can name them. I think that's pretty important. We didn't. Ours looked like this last year. Ours looked like the giant confusing thing. And if you're someone who did not do that, you're going to want to. It's going to be a lot harder to fix something. Like you're like, why is this one part like this? That doesn't work. How do I go fix it? And you're looking at a massive wall of extrude 1, extrude 2. It's going to be a lot harder to like fix that than if you know specifically where every part is. And then top-down design. So this is something that is probably a lot more complicated than I'm going to touch on here. But essentially, you want to design things separately. Like, you don't want everything in one massive file together. You want to start with your framework document or your master sketch. I'm going to have another slide on that. Then you want your sub-assemblies. So you're going to design your sub-assemblies based off the master sketch. You can derive your master sketch into the sub-assembly documents, and you're going to design it around that kind of. That's kind of complicated, but there's a lot of stuff there. Ours looked way too basic last year, I think. You want probably more. You want your motors in, like your general motor outlines. You want your plates. So you know how that's going to interact earlier before you get to this part and you're like, oh wait, that's not going to work. Everything's hitting. Here's an example on the bottom from Mechanical Advantage, 6328. Again, another really good New England team. And the top is kind of the same thing, but from FRC Design. Yeah, when you're done with those sub-assemblies, that's when you import them back into your main assembly. And you can like highlight it all and group it, and then you can make those groups together. I think that's also super useful.
And just some of the terminology. The derive is taking it from a different document and putting it into a document. And then whatever you change in the first document will change the second document. And then import is taking finished parts and importing them into the assembly to then build your final robot.
Yeah, so if you have a sub-assembly that you want to change, you can just change that in the main sketch if you have that like mated correctly. So you don't have to go through and change everything in every single subsystem. You just change it in the main sketch.
Yeah.
And then layout sketch, these can get very complicated. It's essentially just a sketch of your robot. The whole thing, as much as you can. There's some things in there you don't want to put in, like chain, maybe if you don't need chain in there, or like a sponsor panel, you maybe don't want your like sponsors in there. But anything that could like collide with each other, any like main rollers or anything, any intake rollers, index rollers, motors or stuff, pivots, main intake plates, maybe a shooter plate or tubes. Not everything has to go in this, but just the main things. And it's defined as a series of sketches that capture the major dimensions of each mechanism, field element interactions, and robot size constraints. So this thing may look like it's just one singular sketch. It's not. It's actually like 10 different sketches. They have a different sketch for the intake, a different sketch for the shooter, and a different sketch for the everything in there. And they have those in folders, make it easier to track everything. Multiple sketches, multiple sketches, usually one per subsystem within the main layout sketch, part studio. Keep everything separate. Again, if everything molds together, it gets hard to like change that later on as a person who doesn't know what they're looking at. Like if you're not the person who did it, it's going to be way harder to change something like that if it's just one massive blob.
Yep, and this will get more complex as the days go on after kickoff. So first you might just start with like, if I use an example from 2025, we might put the different reed heights in there, and then maybe an elevator, and then start putting an arm, just kind of things we want. And then as we figure out what our strategy is going to be, it'll get more advanced, like this one here. Okay, I'll go on a little bit about designing for manufacturing. I know we didn't touch a lot about the on-shape like specific things, but there's just really not enough time to teach you how to do CAD. This is more how do you do CAD for your team and how to set it up. So design for manufacturing, don't CAD to CAD, CAD to build. So basically you got to do something with the CAD you made. Just CADing to CAD isn't very useful. Be thinking, what resources do we have to manufacture parts? For example, a CNC router, 3D printer, lathe, or hand tools. So this will be specific to each team. So what do you guys specifically have for your team that you can produce parts with? And what material do you have? Like polycarbonate, aluminum. And going along with those, how will we manufacture it and what material will it be made of? You just gotta constantly be thinking of these things while you're CADing. Yeah, just keep those in mind.
Yeah, that's one thing that was like super important for us for CADing. Before we had a CNC router, we kind of didn't really CAD. There was no main drive to do it. Having a CNC router was like super important getting us to CAD. So we could actually use the CNC, use the parts for the CNC.
Design for 3D printing. So now we'll just go over some of those ways to manufacture. Strength. So just think about when you're designing, if you want the 3D printed part, it might not be as strong as, for example, an aluminum part. 3D printing can be very strong, but keep in mind layer lines, also overhangs. So if you don't want support on your part, you'll need to design with usually 45-degree angles, so that when it's printing up, it can like draft out. And then speed. 3D printing is typically very fast. So if you, a couple days before a regional, you need a part, consider 3D printing. Design for CNC manufacturing. This is typically more expensive, but keep in mind cost, strength, time. For example, like when you're making some plates, these are typically CNC manufactured. Use standard thickness, so don't just like put a random number. Be thinking like, is this 1/8, 16th, quarter? Expect fillets on inside corners. Don't design a part that needs to like fold or something and can't have fillets in the inside corners, because when you CNC something, you have a bit that's going around, and the bit has a diameter and it's going around in a rotation, so it'll create a fillet on the inside corners. Design with holes for folding down, unless you use tape or like glue, it's going to have holes in it. For billet, I know a lot of teams can't do this unless you send it out to a sponsor, but just keep pocket depths realistic, so don't do like a giant billet part. Avoid small details and fillets. and designed with flat sides for holding the part in the CNC jobs. And final one, designed for lathe manufacturing. This is a lathe. It basically spins a part and takes material off of it. Used when parts are axially symmetric, so round basically. This is great for spacers, custom shafts, and high-strength pulleys. Oh, we have some examples up here too.
Yeah.
So this is this was meant to lathe. It's a pulley. It's aluminum, so this was on our 2024 robot. We couldn't 3D print it, which is what we would typically do with like this one. We 3D print the pulley, but we needed it stronger, so we made it out of aluminum, and therefore we had to lathe it. We can pass these around if you guys want to see. Some custom shafts and high-strength pulleys, like that one. Okay, do you want to go over some advanced CAD?
Yeah.
I just had a question about the last slide. What do you mean by axially symmetric?
Axially symmetric, so any part that is symmetric but like round, like, you have a better way to. Yeah. Yeah. Yeah, so as you're turning the part, it's spinning at a high RPM, and then you usually have a bit or something that is taking off, like a knife that is taking off material from it. So you can't make it variably, like, I don't know, it has to be round.
So like 360 fully symmetric.
Yeah, like a cylinder.
So feature scripts, these are really useful. We use them a whole bunch. They just speed up everything. Onshape has its own scripting language to create custom. Very useful, I made sure to put that in there. These save you a lot of time. They're also very like hard on the computer, so maybe don't overuse some of these. Some of these, like this one, if you overuse this extrude individual and tube converter, like tube converter puts a whole bunch of holes in that tube, and that can slow down your computer a lot. Also, side note, these were made by Julia. That just so happens to be Daniel's cousin.
Yeah, so if you've used Onshape, you may have used Julia's feature scripts. That is my cousin. That is the Julia behind Julia's feature scripts.
Oh yeah.
I used her feature scripts before I knew she made her feature scripts. She now works at SpaceX.
So part lighten, we use this. We use part lighten for this specific thing. Essentially just creates like an outline of everything, and then you can draw ribs in between them. That's what these are. These are the ribs. And we machine that.
This one is also pretty useful. Not as much for seeing like, so it's belt and chain generator. So not as much for seeing how long of a chain you'll need, but just for like, if you render your robot images and you want chains and pulleys in there. I wouldn't add these like early on because it will slow down the assemblies. But if you're taking pictures or something, you want those in there. Sheet metal modeling. So this is my favorite FRC feature. It is actually a collection of features. You can find them on the right-hand top corner of Onshape. We do parts like these with it. So this is polycarbonate, and we actually, it's this piece right up here. It's a coral shield from last year. You basically design it in 3D how you want the final version to look. I know it looks a little bit complicated, but you basically want the inside of it, whatever faces you're going to use, to look like your final part. And then you use the sheet metal tool to create basically this. And then from this, you can export a DXF file, which is basically a flat pattern. So you need to take a 3D shape and break it down into flat parts that you then bend up into the 3D model. To design, or to make this, we use a heat strip bender. So for a heat strip to heat it up, and then we bend it using a sheet metal brake or by hand. This can be found, like I said, in the right top corner. There's a lot of different tools here. You can make corners and bend reliefs, forms too.
Field document. So, what's it? first release Field CAD document. You're able to put your robot in there and see how that robot would interact with like the field. You can copy that to your team's folder. So yeah, you can import that into whatever. Probably don't keep this in your master assembly. That slows everything down a lot. There's like a ton of parts and everything in there. So yeah, that's what we did this year, and I think got really slow.
So as you can see, we have robots in there that we imported from the main assembly. We can then test to see if they can reach certain elements. Yeah, this document is free by first. Usually releases Reddit kickoffs, and then they will update it. I know some things of it were wrong this year, so they update that in the team updates. Assembly mirror. This is a fun tool they just added over the summer. It makes assembly much faster. It basically mirrors parts in an assembly. It does not create a new part, just mirrors placement. So any mates that are on that part, it will also mirror. Great for drivetrain, superstructure, symmetrical systems. So if your robot is symmetric, you might want to consider using this, or even like if your drive tubes are symmetric. You just select what instances you want. So for example, we have this plate with a bearing and some spacers. We want to make another plate on the other side with another bearing. So instead of duplicating those parts, now you have 2 more parts that slow down your assembly. We can just use the mirror tool and select the middle plane, and it will mirror it around to the other side. Yeah, that's it. That's all we've had. So now any questions? I'm happy to answer any of them. Anybody got any questions? Yes.
Is there any major differences between Onshape and SolidWorks?
Yeah, some very big ones. So when we use SolidWorks, so the biggest thing is that Onshape is web-based. Like you can enter it from a browser. SolidWorks is not like that. Your instance for SolidWorks needs to be on one computer. I know there are ways to like export that, but for the most part, SolidWorks is like just one computer. Onshape, you can access from as many computers as you want, even at the same time. I think that was definitely the biggest reason we switched. That more than one person could work out on it, especially without that computer too. So like 2 people from separate locations could work on the same document. As with SolidWorks, that's harder to do.
And Onshape has a screen sharing feature where you can actually see like what the other person is seeing on their CAD interface. Yes.
Have you tried the Onshape cam tools yet?
I have not. I've read up on it and I've not tested it at all.
Yeah, I think, not to like decide for the team, but it's new, and new things tend to have issues. So possibly going into this year, using it may, maybe there is no need to use it. Everything we did in the past worked. Maybe next year we'll look into it, but.
You use Mach 3 then, or what?
What?
What do you use for cams then?
Fusion.
Could use Fusion 360. So we take our document from
Onshape. That's what we had done.
Yeah, just export a step and then put it in Fusion.
I just wish there was less steps to it.
Yeah, and hopefully in the future or even soon, Onshape will take that over.
Yeah, hopefully.
Okay, we have some. Oh yes.
Well, yeah. I guess I could throw out that I've used the Onshape cam. It's definitely not at the same level of like Fusion or Mastercam. It's pretty rudimentary, but we're just starting to do machining in-house, so we don't really know any better, and it's been just fine. We've been cutting parts and everything. If you have a shop saver, you kind of need to go through some extra steps because it doesn't have a post-processor and that sort of thing, but it's definitely usable.
Good question.
Yeah, you mentioned the collaboration aspect. Have you encountered, or when you first started, did you encounter any problems with everybody can put their hand in the cookie jar, but everyone's reaching at the same time, and now there's no cookies? Does that happen?
Yeah, so we actually did it wrong when we set up the classroom. So we had only admins could access the document. So there were actually only like 4 people that could actually access it for the first half of the season. Mostly if kids don't know how to use Onshape, they can't mess up a lot. But generally just don't add everyone to the Onshape folder. Like know if there's like some kids that are like elementary school, maybe keep them out of the folder for now until I learn more about Onshape. And save a backup of your design, so if anything does happen, you have a backup. Yes?
How do you do versioning first?
Versioning?
Yeah, for your documents, like when do you split them and then push back to main or what?
Yeah, so for the most part, we didn't really mess with that.
Fair
We would
enough.
just like, we change something, we create a new version.
Yeah, that's
all
okay,
we
that's
do.
what I-
We like modify something. Now, we got into, what's the thing you can like split?
Yes, branching, yeah.
Branching. We did some of that, and that was kind of a headache, I'm not gonna lie.
For
We
sure.
had like 4 different branches of like the same thing. I'm like, I don't know what's going on here. I think that is useful, if everyone knows how to use it. We'll have to look into that more though. Like,
Yes. If you want to learn Onshape kind of on your own, is there any good tutorials online you would recommend?
yeah. That would be frcdesign.org. It has like from the basic, like most basic thing, to more advanced. It doesn't have like super advanced in there, but it's a really, really good resource. It has like a full like learning course in there. It's like stage 0, stage 1, stage 2. I would definitely use that. I think it's really good.
And also through Onshape, they have their own learning pathway as well. On the circuit like
Yeah.
Onshape
Yeah.
learning.
Yeah, the pathways through Onshape have more than you could possibly ever get through. Plus, they have certifications. I've used, for classes, I've used one, I think it's called Intro to CAD, through Onshape pathways. And it has you starting with, they kind of give you starting models, and then you just do little parts of it. And then as you develop through, then you start, eventually you're on your own. You're done. So kind of, you start partway through the design. If you use more advanced features, which you probably wouldn't get to if you were starting from blank.
Yes.
Oh, sorry.
Oh, anyway.
I didn't have anything to say, sorry.
Kind of a two-parter. So our team uses SolidWorks because that's where our CAD class teaches, and so we just have people come in knowing how to do it. How would you go about kind of training newbies on how to use robotics how to use CAD for robotics specifically?
That's a good question. With principles for FRC specifically, I'd say have them look at other robot designs in CAD. So Chief Delphi has a lot of great resources for that. In the off season, teams will post their CAD, and then you can actually go and look at it and see all the design choices they made. Really like designing for FRC, the more like matches you watch, read Chief Delphi, I don't know, just get to know FRC a lot more. Doing that.
Yeah, for SolidWorks specifically, I'm not really sure. I know, so frcdesign.org, that's specifically for Onshape. That's like a really good resource though. Like if I were you, I would maybe attempt to move towards Onshape.
And the second bit, how do you guys delegate tasks for like different parts of your robot to different CAD vendors?
We haven't done a lot of that because our CAD team was very small last year, but I think this year we're planning to have I'll probably be the lead CAD kind of like coordinator, so I'll oversee like the whole robot coming together, and it'll have separate people branch off to build different mechanisms. So like we saw earlier, there was the folders with like drivetrain manipulators, have like 1 or 2 people each working on one of those, and your CAD mentors can go along and like double check people are doing things as expected and see if they need help with them.
Okay, thank you.
We have a couple questions for you guys. We're just wondering who, for their last season, 2025, used CAD to build their robot? You. And then which softwares did you guys use? Yeah.
SolidWorks.
SolidWorks?
We use Onshape. We dove into SolidWorks like a couple of years ago just to see if it would be right for us. Everybody says it's the best, it's industry standard, and clearly it is. But there's just so many like convenience things that you lose by going to it. We had to stay with Onshape. It's hard to beat.
We've been using Onshape, I think this will be our 5th year. We've used architecture before. We had a lot of problems with versions and trying to verse things. And with multiple people working on it before it. So it's been a great thing for our kids.
How about you guys in the back?
We use Onshape. This year is our first official year using Onshape. Moved from Fusion.
Confusion.
And then is there any specific CAD problems you want solved before you leave? We want you to go out of this class with no questions about CAD. Teach as much as possible. Any further questions? Yes.
I'd like to hear a little bit more about that file structure, about halfway through, what the deriving is and the importing.
Yeah, we can go. Yeah. This one?
Yeah.
Yeah, this picture is kind of small down here, I guess. But from your master sketch, you're able to derive that into different subassemblies. And then if you reference that sketch in those subassemblies, then changing this one document will also change that document. So you're able to change everything, all these subassemblies, different subassemblies, from one main sketch that may not necessarily be like specifically from each one of these. And that's, deriving and importing.
Yeah. So, like, for example, if you wanted to, you got like most of your robot done, and then you wanted to change your frame size. I'm not saying you should do this, but generally, if you made the CAD good enough, you should be able to change your frame size with just like a single dimension in the main sketch, and have your entire robot change all the way to the final robot without any errors if you did it right.
How do you generate the master sketch? Like, where does it come from?
Just sketching on different planes. So using the sketch tool and the plane offset tool a lot.
Yeah, it's like, how do you like come up with it, you mean? Or?
I mean, how does it connect to the models?
That's the derive feature in Onshape.
Where do you start?
Where do you start?
Where do you start with that? Those drawings where you start, right?
Yeah, like where you started all this, you start with the master sketch, probably not even specifically in Onshape, probably on like a whiteboard or something with your team, and you slowly build up to build the master sketch into something that you want it to be, and then you begin in each individual subassembly designing the main robot. Yes.
What's all contained in that master geometry sketch there? Is it just like the main points of like where everything needs to be, or are you actually drawing plates, profiles,
it's
and
not everything, but it's like main plates. Like there's their shooter tube in there, their A-frame is in there, their bumper. What else? They have their swerve modules, especially on the side view. What else? It's kind of just like every main thing in there. They also have their rollers, their amp mech, some things they're missing are like, I don't think they have the chain. They do have the chain in there, but they have like their battery. I don't think they have sketched.
Like electronics, you generally don't want to sketch or use CAD.
Some of their other plates they have missing too.
So pretty complete. It's not just
it's like their master sketch is like their robot in a sketch. It's like pretty complete. Some things they've added on afterwards though, like they don't have these like vision cameras. They don't have that in the master sketch.
Sure.
Some of the other things they're missing. Yeah.
Any other questions?
How do you like set the material to like define the total weight of the robot? Or do you not really use CAD to estimate what your final weight will be?
You can right click on the part and you can assign a material. Generally you want to do that in the part studio, and then it will, when you import it into the assembly and assemble your robot, it'll automatically show your weight. Some things you may not be able to add a weight to, like your bumpers or something, if there's like different foam materials you use. Yes?
Does Onshape have a stress analysis at all? So like you can add forces and seal the metal over in?
Yes, I think it does. We have not used that though. I think SolidWorks may be a little bit better tool for that.
Do you have access to Google on this?
But yeah.
One of the things I was going to mention when you talk about driving too is when you're drawing, make sure you know what the intent is, the intention. So you want the part to be centered on a piece versus 2 inches and 2 inches from the 2 edges. That's the intention. Now as you change it, it'll always be centered or it'll always be 2 inches from that. 2 different intentions.
So here's frcdesign.org. Again, a really good resource. So this is what they have for their master sketch, like requirements. So they have drive base, wheel locations, most like roller locations, motion paths. Sometimes like gears, gears or chain. If you think that's gonna like hit something or your motor, they put that in there. Some things they say don't do. Mounting holes. Yeah, you don't want like a bunch of holes in your master sketch. Yeah.
I think we're out of time, so thank you guys for coming. If you have any questions, my sister calls me a little bit. It's time to
So I would not change any robotics team for using those shaders.
All of
together.
and it fit. Having parts fit all the time would be pretty cool. That's pretty neat. I'm not going to
Getting deeper in solves. Or maybe like you just said, being able to take your master. So you got hiring people.
It's not like specific. They go back to you. So yeah, I'm working on this. Someone else working on
Yeah, same person.
Started.
Put in your
Yeah.
So you go back to your
The last two.
Thank you very much for this class.
No, we don't.
See you together. Okay. Are you actually?
I do it.
They just watch the entire thing.
All
It's like,
the way to.
Yeah, I watched it with you.
That was it? That wasn't
That was
Oh, you need to go watch it.
Here, I have an idea.
Hayden's gonna burn at least.
Yeah, it's not taking, he's got you. No, I'm sure.
Someone has an idea to slap it.
Was that your password?
No, it's on Zoom.
Just go watch it. It's a good movie. And it's full of records.
I heard the end is not. The end is half the camera dead by more. Jeez. What are they pulling? It's half a town. 5, 6.
There's like, you know how many characters there are? There's like a lot.
She's probably gonna try to see if she probably
Yes, the ball now. I told you. It's not really
Spring Bonnie.
Yes.
An average watcher. I don't know if that's very long. Not
We don't know yet. All of them?
That is not bad.
There's not. Oh, it's going in.
Everyone says that one.
Yeah, that one's
Yes.
That's why there's 3. This one's 7. That's the reason.
Yeah, totally. That totally. I don't even know what that is. Yeah, totally. I'm actually great.
I do that at night.
It's so much worse.
I feel like it's
gonna fade into this.
The start is getting dropped, right? It's getting dropped down.
Yeah, I was gonna do. No, it's the same. We'll see.
You won't realize what I did. I promise you won't. No, I promise. This is like it is the easiest change. I can do that on my anyways, I can test it. I could technically test it. It was 7 out of 8 days. I didn't do anything. We'll see actually. You realize anything.
Change your font. Make your batteries.
Wait, so he can read this.
This is really
You won't get mad at me if I do.
Hold on.
As long as I message, hold on.
I didn't use the laser pointer. I just wanted I think that's
I think mine is the turtle.
This time? How do you make a ball?
Really? I don't think. I believe you.
We have two different
I need to make a story. No story.
You can just make it through to I'm not sure those are the ones, but I asked Okay, let's get started.
Yeah, but I'm
Introduction, I am Dylan, I'm from 4607, I have 2 states. One blue ribbon for electrical and 1 regional win. Should be more. Agenda. Setting up batteries, testing, documentation, breaking in, safely handling it, and pre-master testing. It's just a basic rundown of what a battery would do in its life and what we do it for. So we gather materials. We have big lists. I'm just going to cover the big ones. We use door lock washers. That's these ones. These are the washers in between the nut and the bolts, and even the plug too. It is just a washer we found that works that doesn't loosen as much as when wear happens, and it is pretty reliable. And cut our wires usually to about a foot in length. That usually some teams go for shorter based on what robot they have, but we try to keep it consistent for just in case like we have to borrow ours out. We can borrow ours out just in case, and we do that every once in a while. We got decent batteries, in my opinion. Carrying lugs, stripping wires. We have Kinetic, not lineman pliers, like wire cutters that are really good for stripping out the wire. I would say that's kind of a skill thing, stripping back wire, but that's something you have to do. Securing lugs, we have a hydraulic crimper we use, which it's a process, but it works very well, and we haven't found issues of it coming off the wire in any way. And it's just been reliable. Front heat shrink, I think we got some new heat shrink recently, and it's, I don't know what size it was, but I don't remember. But heat shrink, we just have a heat gun we put it on with, and it's nice, reliable, and hasn't failed. Oh, also the heat shrink is has glue in the center of it, so it does not slide up and down on the wires. I know some teams do like tape around instead of heat shrink. We found heat shrink most reliable for it's consistent every time, and there's less error that can happen. It's just something that we try to keep the same for every battery. Oh, testing. We use CBA. I'm not going to pass this around because it's a little expensive. We test with those settings. You want to take a picture if you want to use it. We have found this is the most reliable, and it is, I would say, pretty accurate for these batteries. It's been testing really well. I'll show the data after the presentation, because I don't have that on for these current ones. And we test every battery up to 3 times right away, but if they're testing a little below average, like 2 hours last year, we test them up to how much it needs. Last year was a battery up to 8 times, which is surprising for these batteries. You should probably not test them that much, but it's something you need to do if you want every battery at the same level. And we test batteries every single year, see if we're able to redo them or reuse them, but most batteries are drained out by then, and I'm trying to hope to start testing between competitions, which allows to see if any battery is going down a lot in between competitions or is going up from the break-in or anything else. This is what we use for documentation. This is probably not the best way to do it, but there's multiple ways to do it, and there's multiple kinds of ways you can do it. We just do what ID it is, the date it got tested, and the amp hours. That's what we test for every single one. It's been reliable. We haven't found issues in documentation like this, but this is how our FNA does documentation, so we try to keep in the same manner of way. Break-in batteries, it's mostly testing them and running at week zeros to break them in mainly, and we try to not let the drivers to brown out any batteries, and that we found that would ruin them in our scenarios since we are trying to play at high levels, and that's something we try not to no browning out and limiting the weeks. Run literally like lightly between weeks running up to regional. That's just making sure every battery is getting charged and have them use an old battery in our scenario that we have plenty. And just try limiting drivers or safely have probably not the best person for this, but we try to have one battery per person. They can't handle more than 2 in most scenarios. But in like some scenarios, like it's perfectly fine ground and you got good shoes, I found out you could probably carry 2, but I try not to. And no horseplay while using batteries, and pay attention. That's make sure you don't stop. Pre-mass testing, we use a battery beak.
Yeah, we use battery beam to test our batteries, which we have found the most reliable way to test them between matches, and it's consistent. That's mostly why we use it. And we also, on this, there is different channels where, see, right down here, it's resistance. We test for resistance with the battery beak on every single battery, and to see if they are up to our standards and see how well they actually are. Test for voltage and resistance we started doing. We aim for 12.8 and between 13 for voltage, and resistance is lower than 0.23, which it's the what battery beak shows on their end. I'll pull up the So this is for every battery has the battery ID. The manufacturer just keep. We usually buy the same batteries. We buy these batteries because it has been consistent for us, and we have not found any errors with them. This is all the tests we have for our batteries, every single one. So there is number 2 is one of our bad batteries last year. I don't know why. I blame the wire because the wire was not the high quality wire we normally use. It's testing below average on our scales, and it did come up on the 7th test, which yeah.
Is there a reason you don't just use the aggregate graph and the CVA battery tester itself? Because it gets you a really nice curve of your voltage and amp hours over time.
I'm pretty sure this is just the way we've done it, and it just a spreadsheet. It's a lot easier. You can see all of them in one place, and see you can make your own spreadsheets. Your sheets. I don't know how to do that anyways. That was Michaela last year, or FMA person last year. And see, they did break in at like the 7th test. It tested really well. And there is battery number 12. Problem 10 is up to test 8, which we normally don't do that high, but that's what happens when a battery tests lower than what we want. and we have resistance for every single battery. So we test the resistance with the battery 10 times. We average that, and that's what's on the average for our label. I forgot to mention this. It is a label for every single battery. It's computationally. It's what the ID is, the date or the last day it's tested, the initials of who made the labels, how many times it got tested, the average amp hours, and the resistance at the end. So that is just a label to cover all our bases and make sure they are computational. Yeah.
How long does it take to test these batteries?
Testing takes between probably 45 minutes to an hour with our settings. Depending on what settings you have for the CBA, it will become less or more. And that's just based on settings, mainly. That's mostly it. Anything different what you guys do for batteries, or it's mostly the same? Yeah.
We get like 17 and a half amp hours out of our testing usually for batteries.
I'm guessing that's mostly settings.
Yeah, I figured. I just didn't know what that meant here.
Yeah. It's based on your settings. Yeah, it's based on settings, probably how old your CBA is. But if you keep consistent settings and consistent what test you're using or tester you're using, it should average out for what you guys use. It's all based on what kind of setting you guys have. See, ours is based, I'm guessing it's based off what the battery is. I'm not sure how he came up with these settings.
Yeah.
That was more of a mentor.
Well, they have standard ones that you're supposed to use first, and those are it.
Oh, I know that.
Yeah.
I thought you had it hand off. Anything else? Any questions? I mean, I think good. A little short though, so I don't know what you guys are supposed to do after, so.
Nope.
All empowered in my goal.
Probably with the robot.
Okay, podcasts are usually videos. I'm just Because they're gonna show videos, not audio files.
What are you guys looking at? What are you guys gonna podcast about?
That's also my second picture. What the heck is?
Yeah, probably about the team to raise money.
But really, that's what it's gonna be. That's kind of a bad podcast. Who's gonna listen to Little's old 4009?
We can make it like
Oh, yeah. On his forehead. You want a jumpsuit shirt?
Sure, what size is it?
Medium.
Oh, sure, yeah. Selection. Yeah.
Oh yeah, this guy's fried. What are you doing? Oh wait, no, that's a horrible walk. That is unlucky.
No, you're not a good kid.
Oh.
I Lucky and Twin.
No, it's gonna be value.
Elbow you in the face.
Brown.
Yeah, how did those shitheads get a hit on that?
Is he literally just logging for your tower?
He's been rocketing my tower, dude. This fucking, oh wait. Put in work. Put in work. Right here. Oh yeah. Who in the hell uses? Oh, he's fucking. He's saving up for a rocket. Right here. Shoot, they got hit off, but it's fine. No, don't lock onto them, Dark Goblin. No. Dear God, no.
Nobody got anywhere.
How did none of them connect with his tower? If you didn't have a rocket, you would have lost that so badly.
What the hell is it?
What time was this class supposed to end at?
Let me look. I think 3:15. Yeah, 3:15. We still got like 25 minutes.
Thank God there were no adults in here, bro.
Otherwise, there would have been that one 40-year-old man who was about all the technicalities about how that one battery can blow up and fucking kill you.
Alright guys, so he didn't go through everything, so let's stay here an extra 30 minutes and talk about nothing. Doesn't that sound fun?
close the door. Oh yeah, there's never class period. Did he leave the room? Just, oh my god, guys, we gotta see how much FPS we can get in Minecraft. Why is this monitor just like so low quality?
Tesla, do something though.
This monitor is just freaking like 720p.
Alright. There's 2 crownless guy. Okay, okay. Something. How many okay, I got 10 crowns.
Okay, we gotta see how much FPS we can get in Minecraft. We're almost here.
Alright. I need 3 more wins. Or 2 losses and 2 wins.
Okay, I almost, it's thinking very hard, and the fact that it's taking this long to load the web version, it's kind of sad. Okay, there we go. Oily man 36. Yep, that's gonna be my name.
There is a camera here. Don't forget that.
Oh, my bad.
Okay, so this guy has an elixir pump.
He has an elixir?
No, he has an elixir pump. Yeah.
$19.30. Yes. Alright.
Did you see the group me notification?
6:30.
No, I just activated King Tower. I'm so stupid. Oh, he has no elixir. He actually has no elixir. I have to go hard on this boy. Okay, he has nothing. He has nothing. Okay, all of them are targeting that, which is suboptimal, but it's okay fine.
You just wanna walk around?
Give me 2 seconds. That sounds fun.
Cause I literally don't know what else to do.
Get him. Get him. He's trying to beat down the beat down. And we swap lanes, and that was his tower. No! Shit, that's so unfortunate.
4 on 5 with Windows 7.
Oh, that is so unfortunate. Yeah, yeah, yeah. I almost, if only I had a fireball, dude. What did Jay say? No, it was after that.
Oh, wait, sorry.
Was it the one for that room?
Yeah, no, you're all good. It was already missing. I just wanted to, I wasn't sure if you had it or not.
Oh, I was just wondering if one of the previous presenters.
Oh, yeah, no, 100% was one of the previous ones.
Because I know the people that previously presented there.
Oh, yeah, no, it was missing since like the second or third one. I just was wondering if it maybe migrated back or not. But thank you.